What's
Earth
going on,
is
everybody?
very flat.
Oh, I didn't know that played on startup. Oh, well, you might have heard the new clip we got. Here, let me play it just for fun since it already sort of played. Here we go.
The Earth is very flat.
Thank you to Rumpus for being a good sport and providing us with that sound
The
clip.
Earth is very flat.
The Earth is very flat, according to Rumpus. Thank you, Rumpus. What's going on, everybody? It is Tuesday, February 2nd, 2021. Hope everybody's doing all right out there. I am Brandon, host of Brandon's Show. And we got some stuff in store for you today. Yesterday, I kind of teased that we were going to talk about the founding of NASA. Hopefully, we'll get to that today. Hopefully, everybody can hear me out there. I think you can hear me. Let me check. Yep. Give me a thumbs up. I see I see something from Chrissy saying that she didn't get a notification. Did anybody else get a notification? Just wondering, because I got this weird message in the middle of the night that said that I was locked out of my channel because it was for children. I don't know what the heck happened. I had to go in there and verify that I was 18 and give them all this information. I thought it was a scam for a minute, but it was a legit URL from Google, and then it let me back into my account, but whatever. Yeah, so let me know if you got a notification, if anybody did. I seen a lot of no's, so that's no good. Okay, well, maybe click and unclick the bell, see if that works. Let me know. I don't know what the deal is there. Anyhow, so back to the show. What do we got going on today? So Sensible put out a video on the satellites in the clouds, a supposed debunk. So we'll talk about that and see if he had a compelling reason for why satellites are falling towards the Earth and appearing to go into cloud cover that appears way too close to the rocket at supposed 576 kilometers. You will also notice that my technical issues have mysteriously reappeared, and I am very, very frustrated with that. But I will continue to work on that. So if anybody knows an expert in OBS, let me know, because I have to figure out what the heck the problem is. Anyway, what else do we got going on? Yeah, so creepy NASA origins. Pebble. I talked to Pebble earlier today, and he had some more ideas for our tangible measurement of the Earth's surface. So we can talk about that. I'm sure that'll come up. I see Jeremy in the Discord, as well as a bunch of other people. But let's say hello to everybody in chat. We've got Balanced Truth. Yeah, hit the like on your way in. Yes, very good, Balanced Truth. Thank you very much. Page 42. What's up, page 42? You said be careful. You need to do something because they will take you down if no disclaimer about kids. Maybe it's your name, Toy. Oh, boy. Yeah, I've had to deal with that my whole life. Okay. To figure out how to get around that. Mark Collard, Cleary, Ian Adams, Rufus St. Hubbins, Fuzzy Bush Monk, D. Ross, Hickory Nick, Chrissy Heavey, and let's see who else. Flat for Life. What's up, Flat for Life? David Wrestler, Flatzoid FE, and Jadu. David Wrestler had a comment earlier. Hey guys, I found Plumb Bob's site. It said they had hung Plumb Bob down a mine about 4,000 feet apart overnight in a pan of oil to dampen them both. In the morning, they measured the bob at top and bottoms, a distance, I don't think he says, turmeric mine testing. Yeah, that's come up a few times over the years. And the thing with that is I think it was used by this very religious group to support concave Earth, if I remember correctly. I could be totally wrong, but that's what I remember reading. We'll have to look at that sometime because it is interesting. They did hang Plumb Bob. They did all kinds of experiments, dropping stuff down mine shafts and trying to measure the deviation from plumb between Plumb Bobs or where they calculated that the ball or whatever should hit that they dropped. I don't think any of them really bore anything that you could call as good evidence, but we'll have to take a look at that. Might be an interesting experiment to do if we could find a long mine shaft like that. And I know there was deviation. They blamed it on all kinds of stuff, wind, the metallic content of the mine, all kinds of crap. But anyway, yeah, there must not be any notifications going out because you normally have more than 34 people in here by now. Hopefully they see the stream, but I'll have to figure out what's going on with that. Mark Collard said, go to speedtest.net or fast.com and check your upload bandwidth. Yeah, it's not the upload bandwidth. I tried that. I tried it on a different internet connection. I tried a different software. I tried resetting everything, restarting everything, deleting files, all kinds of stuff, making sure everything else was off that could possibly interfere with it, changing the server. I mean, it's just been an ongoing battle. It was working beautifully at the end of last week. Like, I didn't even have to think about it. It was just going in the background. Nothing was happening. No reductions. It was just holding the bit rate perfectly. And all of a sudden this week, it just decided to shit out again. I don't know what I did differently. I didn't change anything. So I don't know. Maybe it is some kind of network issue downstream or something that's impacting me, because when I fixed it previously, the last thing I did was change the YouTube server that I was sending it to back and forth. So maybe I'll try that again tonight. But anyway, enough of that. Yep, I've got it at 722, and that didn't do anything. Didn't change anything. So I don't know. Thanks for the ideas though, Mark. I do feel bad that the quality sucks. Actually, it's a huge pain in my ass because I have to watch it constantly and then restart it constantly, and cuts off conversations and all this shit. But anyway, I'm sure you can tell I'm not too thrilled about that. But let's call my ISP. Yeah, no cap. Nope, no cap. I've got what is it when you have 1,000 megabytes per second? I've got like 40 upload speed and 900 and something, like the highest you can have for download speed. I don't think that's the issue because I have tested it when it shits out, and I've been testing the speed at the same time, and there's no change. So anyway, I'll keep working on that, guys. Sorry about that. I do apologize. But anyway, as it crashes again, let's see who's in Discord. Let's go say hello and get things going for the night.
Montreal, you got to hang around, man. Don't go anywhere, right?
I'm here, brother. I'm here. And funny, I used to be the young schmuck with all my friends. Now it's the reverse.
What's up, guys? How's it going?
What up?
Hey, Brandon.
Hey.
Hey, Brandon. How are you?
Good. Effie, good.
Hello. What ho?
And you probably heard who's in here. We've got Effie. We've got Travis, his ether bandiness from the road, I take it. Jeremy, Jimbo, SE Montreal, and the real Bob Dole. What's up, guys? Hope everything's going good today.
Did you got this all, man?
Do any of you guys get notifications in YouTube? I'm getting reports that the notifications didn't go out.
I've gotten them all day. Oh, you mean for your show?
Yeah.
I get them.
I only saw that you were live right now. I didn't get the notification, I don't think. But
I have an alarm. I specifically
got it,
have
Brandon.
an alarm set for this show.
You did get it, SE. You got a notification.
Yes, I did, Brandon. Yes.
Okay. All right. Thank you. I don't know what's going on there. I'm having all kinds of weird crap.
Yeah, if you sub to a YouTube channel and you don't watch at least 4 minutes of a video, it will unsub you at any time.
Really?
Absolutely.
What, after a certain period of time, it unsubs you if you don't watch 4 minutes?
If when you sub to a new site, you don't watch at least 4 minutes of a video at that site, you will be unsubbed at some point.
Huh. Okay.
It's fucking stupid.
Yeah. Who are they to decide, right?
What the fuck?
Hey, I cut out that clip, Rumpus saying, the earth is very flat. So if you listen to it on YouTube.
Flat.
I didn't get
flat.
the extremely flat, but I did get the very
incredibly.
Incredibly
Very
flat.
flat.
Yeah, no, it was incredibly.
Sorry.
You're right. And then he said very flat in the second part. I had to cut it off just right, so we didn't hear him say after that, but it is a ball or whatever he said. Because I didn't hear that part. That part doesn't exist, obviously.
Yeah.
So if you listen on YouTube, you'll hear that. But thanks again, Rumpus. So what do we got going on today? We can talk about NASA. Sensible put out a video supposedly debunking us when we were talking about the satellites falling into the clouds. It was
If
pretty
I may add
neat.
one thing before we get into satellites, Roger Spurrier, who does Mud Fossil University, is so pissed off at flat earthers, he's sort of quitting his
Why?
research and stuff. He thinks we're jinns, demons, and evil, and sorcerers, warlocks, evil, and he can't focus no more because of us. We ruined him.
What did we do to him?
I
What a
don't know.
pussy.
We go to
Yeah.
his site and we tell him back.
I'm with Travis. I'm with Travis.
Hey, if
on
we
that
were
one.
jinns, we could
Travis,
grant them 3 wishes.
Travis, you're a gin, you know it. Come on.
I take my gin shaken, not stirred, 2 olives, please.
We should talk about Pebbles at some point.
Yeah, Pebbles. I've got some info from Pebbles. He got a hold of me this afternoon. He's got some ideas for the experiment, so we'll talk about that. And then what else we got going on? That's about it. So we'll get into that in a little while. I want to talk about this Mr. Sensible thing. For those of you who haven't listened to the show in a while, there was a video that was sent to us by Professor Phil Bell. And in this video, it shows, well, it's supposed to be evidence of rockets going up into space, mind you. It shows satellites that clearly look like they fall into the clouds. First of all,
And also,
why are they falling? Second of all, how are they that close to the damn clouds? And they also look like they have parachutes on them, and it's just
it's
obvious
also
space
extremely,
fakery.
it's also extremely apparent that when you juxtapose the photo from that with a photo from any high altitude balloon, that they are clearly not as high as they claim they are.
Yeah, absolutely. So Sensible put out an 18-minute video, and he was trying to make fun of us, I'll argue, and saying that it was an optical illusion because of digital artifact that along those lines, right? And that they weren't falling into the clouds. It was perspective. You can probably see my comment.
But what's the excuse for why it's so abundantly apparent that a high altitude balloon is vastly higher than the Indian people claim to be?
Well,
Is that an illusion too?
that was because of the poor quality of the video, and his footage, he
So
says,
we're
wasn't zoomed in, but this footage was zoomed in, I guess he was saying.
So we're getting such great definition of the clouds because it was such a low quality camera.
Yep, that's it. Exactly. He
sense.
said those clouds could have been continent sized. You don't know. You don't know how big they are.
We could see the definition in them though, like clear. You could see them going up, down, all kinds of angles of the cloud. Whereas in the main two, my bad. Go ahead.
No, that's all right. Since I'm not a satelliteologist, when would they stop falling to, maintain their orbit around
When they hit the
Earth?
ground.
Yeah,
You know what I
when they
mean?
hit the ground, conservation of momentum.
Right?
Well, that is an excellent point, Travis.
Yeah, that was one of my first questions.
They're
when I'm
going
watching
to
this,
say
like, why are
they drop
falling?
them from higher than their orbit, and then they lock into their orbit depending on their mass and weight and speed when they get to it.
Yeah, Sean
That's
G
fucking-
told us
Makes
that.
perfect sense.
That's
Sean G
fucking
told us they're gonna.
ridiculous.
Sean G told us they're gonna fall into their orbit, if I remember correctly. So apparently, if you just drop something,
Yeah, something like that. They're going to magically lock into the orbit because they're not falling. They're in orbit. It just looks like they're falling.
You got to be wholesale gullible to believe that crap. So they got millions and millions, according to Phil Bell, millions and millions of dollars worth of equipment that they're just basically throwing out the back of what looks like a C-130, and they're just trusting that it'll just fall and just lock in randomly under no control or no guidance. Seriously, Phil, you have shot your foot off with this video. You haven't shot yourself in the foot. You've blown it off completely.
Why would you bring such a terrible... Oh, my bad. Go ahead.
I would, well, I forgot what I was going to say. Go ahead.
I'm just curious as to why you would bring such terrible evidence of the one thing you bring. I would bring the best thing, the best piece of evidence, not the one that clearly is fakery. That's just me, though. I don't know.
No, I think that would be a good strategy, Jeremy.
That's a good strategy,
I tend to agree
right?
with you.
They only had fakery to go to for the most part.
Yeah, but
The
you
whole
got
thing
good
is a
fakery
scam.
and yeah, but you got levels. You got good fakery, then you got shitty fakery. You know, bring something good at least. I would have brought the best looking one.
NASA probably
Just
sent some people over to India, and they worked over there for a few years trying to teach them how to fake it. You know, it's like a partner program, right?
Yeah.
Did I hear correctly? Did they say that they're not falling now? And what did they say before?
It's an illusion. Well, they've been saying it's an illusion from the jump.
Yeah, but the trajectory, it's going down to a lower orbit. Is that what they're saying now?
That's one of the excuses. Sensible didn't say that. He essentially said that they're disappearing because they're getting so far away that you can't see them. He was claiming perspective. Yeah, that's what I thought too. Yep. So they disappear into the clouds because of perspective. And he said, well, it's so, fuzzy.
Well, I thought it was digital artifacts. Is it perspective or digital artifacts?
I think he said both. He just threw. He had a cornucopia of excuses in an 18-minute video. Pinata. Yep.
The
both.
filing cabinet of excuses has opened.
Yep. And he was just pulling it out of there, mad, just throwing them in there, just throwing the files in there.
And the camera's got such great zoom that it can zoom in from 400 kilometers away and give us perfect definition on the clouds. But after the satellite's it's been falling for 3 seconds, we lose it.
But it's a shitty camera. That was one of their excuses as to why something's happening, because it's such a shitty camera, but it's so good, yeah.
Right. Yeah, he didn't appreciate the comparison to Mage 2, but he kind of skirted around of it. He didn't really address it. Like, I don't know. He could have done something like calculate how much time it would have fallen. It just wasn't very impressive. A lot of excuses. I did invite him to come on in and talk to us about it.
Oh, my bad. Go ahead.
No, that was it.
When you look at the photo, much definition in the clouds is fucking. You're a retard. Sorry, I don't want to call names, but you're just dumb at that point.
Well, I mean, ultimately, if anybody was going to look into this or prove their case, we would have to have the statements in the specs that is exactly what the satellites were going to do when they hit their orbit altitude, that they were going to just fall in like they hit this river of ether that just swept it along, right? Right? I mean, if that's what you're going to claim, because most of that's ad hoc, right? So if these guys, let's just say Phil Bell never thought about that question. And so then I said, well, how does it stop falling how does it becoming an orbiting satellite? And if he just says, well, it's just going to fall into the orbit and just catch up or whatever. And I say, okay, can I see that in writing, that that's what the specs say is going to happen?
Yeah, good point.
How do they know? Right? How do they know? I mean, this is the whole thing. When you're on the Earth and you're looking up and you're trying to figure out how you're going to project a rocket where it's going, you don't fucking know what's up there. You don't know what it's going to experience. So you have to get up there and go, holy fuck, when we got to 120,000 feet, there was this massive surge of river of air. And that's where we need to put the satellites. We got to get them right there.
Well, there can't be any air. Data? There can't be any air where they're dropping. This needs to be in the vacuum.
Yeah, in their fantasy, there's no air.
Yeah, there's no air.
Well, there's
I know what you're
atmosphere.
saying, though.
There's
I know
lower
what you're
pressure
saying.
atmosphere, right? I mean, there is
Yeah,
air.
no, I got
I'm
you.
just-
Yeah, I know what you're
yeah,
saying.
yeah. So yeah, go ahead, Phil. Full of bull.
He blamed the apparent parachute, which I thought he would latch on to the, it's an exo brake excuse, because that's a handy one that they have available. But he just said, no, it's tumbling and it looks different because it turned. Which doesn't really hold much water to me, because you got these three things. They're falling one after the other. The two that are closest to the ground develop these white things, and then the third one develops this white thing that seems like it's offset from the center of the satellite, just like a parachute or whatever would be that was deployed out of it. So, I mean,
Real
that's
quick
like the
question.
least convincing thing about this video, but I don't even think he addressed that very well.
Real quick question: if it was turning, right? Are these things just tumbling through space all crazy, chaotic, or are they supposed to be like facing a certain direction?
Yeah, good
when's
question.
When's that
Are they just
when's that
tumbling?
gyroscope kick in?
Are they tumbling crazy forever now, or because you would need some kind of propulsion system on it to stop? If it was spinning, what's going to make it stop spinning? You need some kind of propulsion.
Yeah, not only that, but if it's spinning, you're going to see different faces of this satellite. It's going to rotate, and you're going to see.
Hey, Brandon. Sorry, guys. Is there any way to find out what their orbital height is?
Yeah,
So
no.
we can settle this
I
once and for all.
got it from their website. Essie, it's 576 kilometers is where they were supposedly deploying the satellites from.
Yeah, but where do they end up? What's their final orbital destination?
Oh, I don't know. I didn't see anything that went that in depth on these particular satellites. I did find the satellite, but nothing that said
Sea level.
These are going to be it. Yeah.
Sea level.
Well, why are you confused about them descending? Because they were fired backwards out of the thingy. You saw them. Part of this footage is them being shot out backwards.
Listen, Rumpus. When we
Let
have
me finish,
discussions, hold on, no, let me finish. When we have discussions like this, we don't use terms like thingy. Okay, thingies. Don't use that term. Okay, you just drop down to the lower shelf right then.
They were you saw the launch mechanism for these things, and they were shot out opposing the direction of motion, which means they will descend into an orbit that matches their velocity, which would be slightly less than the vehicle they're in. So they will descend, and then they will go into the orbit that's relevant to the velocity they've got. It's really, really easy. There's a simple equation I can show you to go through this.
Perfect. What's the height of their orbit supposed to be?
No,
Right?
thank you.
I don't happen to know what that is, but they are fired out backwards, so they have a slightly less velocity than the orbital vehicle that they're launched from, and therefore they will descend very.
Well, then how are they fired out? If they're going slower, wouldn't you have to fire it out faster so they would go away from you?
Slower. No, they're fired out backwards. So they descend because they're slower.
You mean they were dropped? Okay, they were dropped.
No, they
Listen
weren't
carefully.
dropped. Listen to what I said.
No,
They
you
were
said fired.
Try and listen to what I actually said.
Listen, I've
They're
been gone
fired
for
out
2
in
weeks.
the direction
I'm turned on.
opposite to the velocity, so they have a lower orbital velocity than the craft they were fired from. Therefore, they will descend into an orbit that's
Where's your
appropriate
proof
for their
for
velocity.
this? Where is your
Is that kind of like an
documented proof
aeroplane
for
that
this?
goes against the rotation of the Earth, Rumpus? It doesn't maintain its momentum?
Well, they are maintaining them. Well, they have.
So
Okay.
then what?
Rumpus, where is your documentation to validate your claim right now?
Well, anybody who knows anything about orbital
no,
mechanics,
sir.
there's
Ad
a very
hoc.
simple equation
Ad
where you
hoc.
match. I mean, you're basically saying you don't know the relationship between
That's the fuck right.
Listen. The orbital velocity. There's a relationship between the orbital velocity.
I'm a Spanish
and
swallow.
let me
We
finish
get
my
it.
sentence. There is a relationship between the orbital velocity and the orbital elevation. Now, all that's done by releasing it to the
Rumpus,
firing it out. Let me finish my sentence.
No,
By
Rumpus, you're
firing
not
it out
answering
in
my
the opposite
question.
direction to the craft, you've given it a lower
Stop
velocity.
saying the same
You've
thing
given
over
it
again.
a lower velocity than the craft has got. Therefore, it will go down.
Great.
Finished.
Rumpus, would you please just give me a link with the documentation so I can validate your explanation, please? Thank you.
Okay, well, let's see if I can
I'm
find
not
something.
a satelliteologist, bro.
We should run.
Now,
we
Rumpus,
should run
Rumpus, while you're looking that up, What I'd like to know is we shoot the satellite out of the back of the craft, and therefore it travels at a lower speed. It had momentum of the craft. We've sent it backwards, so therefore it's lost some of that forward momentum that it had, and now it's travelling at a different speed.
Correct.
However, in the never-ending pit of Coriolis argument, when we talk about, hang on. When we talk about an aeroplane that takes off in a westerly direction, you say that it maintains its easterly earthly momentum as it takes off in a westerly direction, and that's why flight times east and west don't alter. So what changes between the aeroplane and the Earth and the satellite and the and its launching craft? Why do those two concepts not connect?
Well, they do connect. They're exactly in agreement. I don't understand the problem.
Yeah, you're going to have to produce documentation that proves that they're exactly correct. Otherwise, you're just a what's the word? What's that word for
Communicator?
No,
Shell.
not a communicator.
Shell.
No. It's like in court when you just have hearsay. That's just hearsay. You're just making shit up.
Well, you don't understand basic physics equations.
That's the fuck right. I don't. That's right.
Okay. Well,
so
you've missed out years
the
of
document
education.
that validates what you just said.
So you want me to fill in the years of education you missed? Okay. Well, I'll see what I can do for you.
But why does the jet maintain the aircraft maintain the Earth's momentum or that it had on the Earth, but the satellite doesn't? It seems to lose that and therefore drop into this mysterious.
Well, it's only different by the amount of. It was shot out by this launch. I can't remember. There's a little vehicle which is used to shoot them out, and it's given.
That's fine. But it goes in the opposite direction, as a plane does.
No. This is. But a plane is powered. These things are just going to drop into an orbit that's appropriate for the velocity they've been given.
They're powered by the thing that shoots them out initially, and you're saying that washes off the forward momentum.
They're not powered. They just have a velocity.
Oh my god!
I mean, if you fired an aircraft, you've got air resistance to it. So an aircraft is powered. Let's go back to the aircraft situation. When you're on the tarmac, on the equator, east to west, pointing east to west, the aircraft is doing 1,000 odd miles an hour in the direction of the rotation of the Earth. As it takes off, it's still it's got to then whatever the takeoff velocity is. Say, I think it's something like 200 knots or something. You need to get an aircraft. It will then have a relative velocity to the surface of the Earth of 200 knots. That's the definition of the true airspeed. Or true ground speed, and therefore it'll have a velocity of 200 miles an hour, 200 knots, minus, depending which way it's launched, plus or minus the 1,000 miles an hour at the equator. And then, of course, because of the air resistance, etc., if it didn't have continuous power on, it would obviously drop to the ground. To maintain that 200 odd miles an hour, that's the launch speed, and it gets up to 500 miles an hour when it's up to cruising speed. So that means that when you say something is moving at 500 miles an hour, relative to the atmosphere. Let's assume that the atmosphere is not blowing around, that it's still air. That means that you're moving 500 miles an hour relative to the surface of the Earth. So the speed in space, if you were to get outside of space, outside looking from above the Earth in space, and you're looking down the aircraft, the Earth's surface be rotating at 1,000 miles an hour, then be plus or minus the 500 miles an hour of the aircraft, and that would be its absolute position in space. Although, of course, the orbit of the Earth is also going along 64,000 miles.
I can't even believe how long you let this guy babble.
Yeah, I just want to apologise to everybody that I've led us into this crap. Seriously, my apologies.
Does not mean to say that it's not true. Just because you're stupid, I'm afraid, does not mean to say you have a right to say what I'm saying is invalid. What I'm saying is incredibly simple. If you understood what relative velocity was, if you understood what relative velocity was,
we don't care. You know what, Rumpus? I want to know why these satellites are falling into these clouds. Why does it look like that?
Because they are descending, because they're at a slightly lower velocity than the craft they were released from, therefore they descend. And therefore, because they're descending, they only need to get away. They're only a foot apart, so they only need to get a few hundred meters away.
They're falling. They're descending. They're falling.
Well, they've still got 17,000 miles an hour across thing, but so's the camera. So you're looking at something,
A cross thing? A cross thing. Is that a technical term?
Yeah, the
stuttering.
So you see, because I'm having to deal with idiots. So the aircraft, the craft is moving at 17,000 miles an hour, and these things, because they were launched at about,
I call that projection, Rumpus.
They looked
Projection.
about 20 miles an hour less than the aircraft. The craft which means that they will then descend into an orbit appropriate for that speed.
It's a good story, Rumpus. It's a good story, and I understand why you think that. It's a good story, but we're watching them go into the clouds. We watch it happen, man.
They do not go into the clouds.
So you're asking us to believe you over our eyes. You know, you're saying to us, what are you going to believe, me and my calculations and my story, or your lying eyes? That's what you're doing.
If you watch the vision, you can see they're not. But if I did what you're claiming, which is they're bobbing up and down in the clouds, then they'd be coming up and down, which obviously they can't be doing that.
Why would they be going up and down? They've obviously got some forward momentum. They're falling, and they also have a. Hold on, guys. They also have a forward vector to the momentum. Obviously, if you throw something out of a plane, it's going to go down and forward, right? That's what we see happening in the video. We see them going down away from the aircraft and in a forward vector. And then we see what looks like parachutes open, and they skim across the top of the clouds or go under the clouds. That's what we see in the video.
They disappear. What's the problem with that?
No, they go under the clouds. They don't disappear. They do. They very, very clearly do.
That's impossible, because if they did, they come in and out of vision on pieces of above flat clouds.
They do. They do come in and out of vision, Rumpus.
If they were doing what you're claiming, then they'd have to be going up and down. They're clearly not doing that.
No, they wouldn't, because the clouds aren't one continuous piece of.
You can see in various pieces
the clouds have holes in them. Have you ever looked at a cloud? It's not one solid mass.
Solid clouds up in the air.
They blink above solid clouds.
Clouds are solid. Let's just focus on that.
Guys, he just said the clouds are solid.
Solid.
Clouds are solid?
Clouds are solid, are they?
I'm talking about the color. The
Clip
solid
that out.
color. Solid piece of cloud
I'm
color.
looking
No,
at,
that's not how it would work.
Colored
No, they're not
right
solid
now.
color either.
I see different colored
Where they're
clouds.
blinking, where they're in front of a solid piece of color. And if they're doing what Brandon's claiming, then they'd have to be going behind the cloud, then at this side of the cloud, then underneath the cloud, above the cloud.
No, they're going through the clouds at a vector to where they go in one piece of the cloud and out the other piece of the cloud. You can see the shape of the clouds, Rumpus. It's very clear. They're choppy, broken clouds with higher spots and lower spots.
They blink.
Have you showed Brandon? Have you showed
Invalidates your argument completely.
Rumpus, can you stop talking for 5 seconds, please?
I'd like to hear Corey Barron's
I did stop. It's just I get interrupted, Jeremy. I'm quite happy to talk.
Shut up.
Yeah, poor Rumpus. Poor Rumpus. He's a victim. He gets interrupted.
Rumpus victim again.
Guys, everybody, shut up, please.
Refrigerator.
Now, somebody asked me if I had shown Rumpus what? This comparison?
The Mage 2 up against the Indian photo with the clouds.
Have you seen this comparison, Rumpus?
That's pretty hard to
I'm
do.
sharing.
Yeah.
That's pretty
What
hard
do you
to
think
get
about
around
this?
The Mage 2 image you've got there is from the wide angle, very wide angle camera. The one on the right.
Non-sequitur.
What on earth are you talking about? Non-sequitur. It's a wide angle camera. What on earth are you talking about?
So what? They're both wide angle cameras, obviously. So what?
There's a wide angle lens with the Mage 2 image, and on the other one on the right, there is a high focal length.
Wrong. What is this? Hey, hold on, guys. Let me get this out here. Do you see this thing on the right side of the screen right here, Rumpus? Do you see this black thing?
I can't see a pointer.
Okay, on the right side of the ISRO half of the picture, there is a black thing. It's got 3 semicircles. Do you know what that is?
3 semis.
It's a black rectangular thing with 3 like white semicircles closest to the border of the video. Do you see it?
Oh, right, yeah, on the black side. Sorry, yeah, sort of the edge of the spacecraft. Yeah, or window,
Okay.
window or something. Yeah.
What that is the ejector. That is part of whatever vehicle this is, the rocket per se, and that is in focus, Rumpus. This is not a zoomed-in image pointed down here. We watch them come out of the ejector and fall. They get farther away. This is not zoomed in. This is a wide-angle camera.
I don't
Not
think
to mention, hold on, Rumpus, hold on. Not to mention that the cube satellites are like less, 10 centimeters a foot in length, and we can see them clearly when they come out. So, this is not zoomed in.
Well, this
would be a good time for you to have a connection issue and just kind of drop out, Rumpus. I think you're about to get home.
It clearly is. The one on the left, we know is a very wide-angle lens.
Yeah.
Right? So
why is that relevant?
And then we can know that. We can also see the fact it's super curvy. The fact that is the wide angle. We're getting some wide-angle barrel distortion. So we know the one on the left is a very wide-angle lens. And
Why is that relevant?
Well, I'm being asked why the clouds look so far away on the left-hand one and close on the right-hand one. And the reason is the focal length of the lenses.
No.
So nothing to
really
do with the wide-angle lens. Nothing to do with
the one on the left's got a wide-angle lens. We know that for a fact. And the one on the right is not a wide-angle lens.
They're both wide-angle lenses, obviously.
No, it's not.
Yes,
no,
they are obviously wide-angle lenses.
No, they're not obviously at all.
Of course they are, Rumpus. That is a weak excuse, and you know it. You should be ashamed of yourself for latching onto that.
No, the one on the right is not a wide-angle lens.
Shame.
The one on the left
Shame.
we know is a very wide-angle lens. One on the left we know is a very wide-angle lens.
Oh, very wide-angle.
Yeah,
that makes a big difference.
I can't remember the detail. I can't remember what it is now, but it is.
The clouds look the same in the other camera.
An utterly wide-angled lens.
Rumpus, the clouds look the same in the Mage footage out of the other camera as well. That has nothing to do with why these clouds look like this, Rumpus. Out of the front camera, the clouds have the same amount of detail in his footage. This had nothing to do with it. There's no detail to these clouds because Mage 2 is so high. Why do we see so much more detail? And we even have some depth detail to these clouds. Why?
On the left is using a very wide angle lens. And the
that's
on the right
just
is
bullshit.
Not.
That's absolute bullshit.
We know this. We know
this. We know this.
Use a very wide angle. So we can see as well the curve, the amount of the Earth curve we can see there is much.
Are you saying we can't get cloud?
We know just from looking at it that it's a very wide angle lens.
Why are you lying to yourself?
We can't get cloud definition?
Why are you so stupid you can't understand what I'm saying?
Rumpus, are you saying we can't get cloud definition in a wide angle lens?
Well, the definition is not the issue here, is it? Sure, it's the amount. The thing I'm arguing against is supposedly it looks like it's more, you can see more cloud. I didn't hear that. You interrupted me.
So we don't get cloud definition in a wide angle lens, you're saying?
No, I didn't say that at all.
The question on the table, what does the wide-angle lens have to do with it?
Because I was asked, why is there so much more curvature in cloud? Why does it look higher? And the explanation for that is it's using a very wide-angle lens. You do know that very wide-angle lenses make things look smaller. Things that are close to are made to look much smaller and more distant, don't you?
We're talking about the definition. Pick this spot right here, okay? All the cameras on Mage 2, these clouds look exactly the same. They look just like this, okay? No definition. They look very, very far away. These have definition and look close. Why?
It's not using a wide-angle lens.
It is a wide-angle lens, Rumpus. It has to be. This piece of the rocket is in focus, and we see the definition down here. That has to be a wide-angle lens, right?
Well, I don't think those things in the distance look terribly in focus. And the clouds don't look terribly in focus. The trouble is the resolution of the image is actually not of the image of the video is not great.
Well, yeah, that's another question I have. Why would ISRO spend millions and millions and put out 480p fucking video in 2019?
Well, you have to ask them.
Does that make sense to you? We're going to film this rocket and the satellite's being launched. We're going to film it in 480p in 2019. You can't even find a 480p camera in 2019.
Well, the camera might be greater, but the streaming the ability might be not great. I mean, there's only a certain amount of data they can using the transfer thing. They've got a little bit
the bandwidth of the satielites isn't enough for their one camera feed, right?
The transfer thing.
We're talking about the transfer. The data rate that's possible, we know there's a problem doing this. The transfer data rate is not great in these things. Unless they're special. This is not a specialized, the actual launch vehicle, this ISO thingy, what's it, is not designed.
With my cell phone, I can get 4K and all that. I'm supposedly connecting to satellites, aren't I? I mean, we're supposedly using satellites to transmit information and data and 4K and all this trillions and trillions of.
This is not designed. The channel that's being used here has not got the capacity.
Oh,
to
can you show me where the information about the specs of the cameras and the how do you know so many technical details about their audio video setup on this rocket here?
I'm aware there are always the high bandwidth information. Communication is always problematic.
So this is something you made up. You don't know the specifics of what was on this rocket. Do you know the specifics of what was on this rocket as far as video and communication equipment?
I don't know what the video bandwidth for this rocket was.
That's what I thought, Rumpus.
But the fact that it's for but your question. But this is with the conspiracy theories. You're always trying to find some idiotic explanation for something as some devious thing, when it always turns out to be someone not doing something quite right, or there being some physical limitation, or they couldn't be bothered to put enough money into it or something.
You know what we're doing here? We're watching satellites fall into clouds and wondering why that is.
What you're not doing, and the image disagrees with that analysis. The fact that they go across solid pieces of cloud and they
what we see, would you agree that what we see appears to be satellites going into clouds? Would you agree that that's what it looks like? Does it look like that? Does it look like that? Does it look like this satellite goes under these clouds? Yes or no? Does it look like that?
It does not.
You're a fucking liar, Rumpus.
No, you're a moron.
Look at it. Watch it. Watch it go under the clouds right now. Did it look like it went under the cloud?
No,
does it look like it went under there?
No, it disappeared because it became too small.
It disappeared. And what did it disappear when it got near what, Rumpus? It got near something and then it disappeared. What?
Solid pieces of cloud and then reappearing, which that cannot means it invalidates your theory.
No, that is so silly. You can tell these clouds are jagged. There's higher parts of these clouds. There's lower parts of these clouds. You can go through one and come out in the middle of the cloud, can't you?
There are blinking events that occur above solid areas of color, which means they cannot be going underneath the cloud.
Nonsense.
Because the cloud is solid and they blink, which means that they're disappearing
nonsense.
And they're then coming back into vision, and they're clearly not going up and down, so that entirely invalidates your theory.
It doesn't.
No, absolutely not. They don't have to go up and down. Stop talking, Rumpus. You've been talking. Listen up very carefully.
Okay, go ahead.
A cloud might have a consistency of solid color, but it is not consistent in its 3 dimensions. So something flying through it can be obstructed by a higher portion, and then when that higher portion ends, it comes out, and then it goes in, and then it comes out. It does not have to be going up and down, which makes your non sequitur ad hoc bullshit exactly what it is. It's bullshit.
I'll explain why.
No, I just did. Thanks.
You're not interested in the answer. You're not interested in the answer. Right, but the answer is, you can see from the right-hand side where the sun's coming from. If it's a uniform color, that means it has to be of uniform angle. So therefore, if it disappears and then reappears, whatever it was over was at a constant angle. It wasn't going up and down as you're claiming in 3D. So therefore,
who said it was going up and down?
Well, Travis just said that he thought the explanation was that the parts of the cloud were higher in elevation than other parts.
Yeah.
But they can't be, because if you listen to my answer, because they're the same color, and because we're getting an angle of reflection from the sun on the right-hand side, they would have a different color if there was some sort of change in the elevation.
Total conjecture. Total conjecture.
Total conjecture.
You don't understand how reflection works on an object. You get areas of color, and that's why also you'll get the white bits on these things are dependent on the fact that it gets further away, and then as they do so, there's a change of angle between the sun and the observer, which means it can then reflect.
So, let me just sum this up, what your theory is here. The satellites go just far enough away to disappear exactly when we would expect them to either go in or under the clouds. That's just a coincidence. The white things that appear to emerge from the top of them is just the sun hitting them just at the point and in the order that we would expect if they were being dropped and parachutes were ejected. It's all just a coincidence. Just
wherever they
just a
disappeared,
coincidence
you
that
would have
it
said
looks
they were
like they're
going out
falling
of
into clouds.
I'm sure if they'd gone twice as far and then gone, you'd have said, "Oh, look, they've gone inside the cloud." But the fact they blink above solid areas of cloud,
Nonsense.
and because Travis's argument doesn't work, therefore they are blinking because they're becoming further away and becoming less bright. And the reason they've got the white spots is, as I'm saying, if you imagine,
you don't have to repeat this. I know you're not stupid enough to believe this, and neither is the audience, Rumpus. I know you're not. I know you're not.
I know,
So anyway,
too
someone
stupid
else
to
was trying to
understand
speak
what I'm
up. Let's change the subject. We heard what you had to say multiple times.
But you
Clint
didn't. I
Torres.
didn't explain the white bits.
We let you get it out multiple times. Clint Torres,
Well,
how's
okay,
it
you're not
going?
interested in the expression of the white bit.
Clint, I think you spoke up.
It's Brian Mabbott, mate.
Oh, hey, what's up, Brian? I thought it was
just
you. I wasn't
looking
sure
at
because of
this
the name.
I thought I'd put my real name on there for a change. I'm looking at this image, and to me, that is looking up from the ground with the sun above the clouds, and the objects are above us. Look at the shading on the objects is at the bottom.
Yeah, the sun is over to the right. You can see that from the clouds.
This is taken from Earth with the clouds above you.
Well, if you'd seen the earlier part of the footage where they showed the horizon, you would clearly see that it's not. You can actually see the horizon, the clouds underneath.
I'm not talking about that. Obviously, they cut it and clip it together. But to me,
well, okay,
that is from
that's just
the ground.
on your part. We could see the footage earlier where you could see the horizon, the clouds below us. So therefore, what you're saying is utter gibberish.
Hey, Rumpus, watch this piece right here, okay? Here's the satellite in the center of the screen. It's coming. It hits a cloud, partially disappears, and then comes out the other side of the cloud, and we can see it. Do you see that?
Right, but it also disappeared prior to that over a solid area of color. So clearly, it's because of the light reflecting on it, it becomes visible and invisible due to the amount of light.
Well, that's a good theory, and you guys are just going with the digital and the optical thing.
But you can't deny that it blinks over areas of solid color. So if you just stop it there,
how can the sun be on the other side of the clouds if we are in space? It's ludicrous.
I didn't hear the start of that sentence, really.
That image is taken from on Earth, and they're looking up at the sun. The sun is above the clouds.
Brian, you're the only person who has this strange idea. If you look at the earlier footage, you can see the clouds are below you, and you can see the horizon and the curvature of the Earth.
How is the sun there? How is the sun there? The other side of the clouds. If we are,
the sun is to the right. The sun is to the right. The sun is to the right.
Well, why can we see the sun there? There's a gap in the clouds, and we can see the sun.
No. The sun is to the right.
No, that's not the sun. It's not the sun, Brian. It's just why. It's the sunlight hitting the clouds.
Yeah, Brian, look at the image we can see on screen here. Look at just to the right of the green circle that Brandon's put in there. You can see a piece of cloud with a bright bit on the right-hand side and a dark bit on the left-hand side. That's because the sun is to our right.
It's all nonsense to me.
Can I just throw in here, just quickly? So Phil works in this industry, and it's just struck me as amazing that there is not some footage available from Phil in this industry that is not so outrageously controversial as this bit of footage that he has supplied us. How is it that the bit that he gives us either is the only bit in existence and is really badly CGI'd, or why is there not some just clearly, obviously genuine launching of satellites instead of disappearing into clouds and all the stuff we're picking apart right now?
If things get small, if things get small, they're going to merge with the clouds in the background, no matter what. That's a basic thing. As they get smaller, they're going to disappear, and therefore they're going to look as though they disappeared into the background. So that's always.
You're missing my point, Rumpus.
I think you did it on purpose.
You'll never see your point.
Well, no,
it's a simple. But you don't seem to be accepting that things are going to get smaller as they get further away and disappear into the background. I mean, it's simple. That's what happens with things getting further away.
All right.
Why is the only footage we've got such awful footage?
It is low resolution. I agree with you. It's not in focus, so that's
not
so
just
good.
the resolution. What it's displaying is awful.
No, it's not. It's fine.
Rumpus, as the newest member of Flat Earth, you're going to have to start using more technical terms and not use like thingy and shit like that.
Well, I try and dumb
Alright.
it down for you guys, I suppose, because I know if I start
Well, no,
talking
you're
about the
not-
maths. So, for
you're
instance,
on
I
our
know
side
that
now.
people
What
like
are you
to tell me you
talking
don't know the
is
mathematical
very
equations for orbital mechanics. So, if I start going to maths, you complain. So, I start
Well, we're
try
all
and
on the
dumb it
same
down
team
to
now,
language you
Rumpus.
might understand.
We all think Earth is extremely flat. We're all on the
Anyway,
same team
if
now.
you're circling the Earth at 17,500 miles an hour, the first thing you want to do is chuck a load of fucking objects out that you're going to hit on the way back round.
Ah, well, that's why they fire them backwards, you see.
That makes
They-
perfect sense to me,
they-
Brian.
They hit,
Yeah,
that's why
and
they
me, I do
they-
exactly the same.
They fire them out backwards to make sure they're in orbit below that of the
Brian,
the vehicle.
that's why you're also dodging all the bits that people have fired out previously as well.
Well, it is a problem. I don't know if you've seen the website which shows all the space debris and all the satellites, and they make a point of avoiding it. They actually change the launch of various rockets to avoid debris that they think
Must
they're
be a
going to
bloody
hit.
slalom course up there, Rumpus.
I mean, if you go and look at the website, it's absolutely chocker up there with rubbish they have to avoid all the time. And so they have, and for instance, they have to make sure
Like a
these satellites
slalom
go low.
course,
They actually give
they
them,
have
I
to
think
speed
also, they give them a
Also-
very slightly different velocity to make sure they don't hit one another and have slightly different orbits. So they're in slightly different altitudes because they give them very slightly different velocities.
Is that the thingies? Is that the thingies that they give the slightly
Well,
different
if
altitude?
you can associate the word thingy with different velocity, then that'll be working wonderfully well. I'll have communicated the idea exactly
I
correctly.
have a
point
question. Those thingies that are traveling in a downward momentum, regardless of what their orbital final destination will be, how are they going to be slowed down?
Well, they're not slowing down. They've got a particular velocity, and that particular velocity they've got means they'll have a particular altitude. So they'll carry on moving downwards until they reach the altitude that's appropriate for their velocity. And then they'll stick there.
Don't
What
they
they
What
stick
the
there?
fuck?
Hold on, they
Did you
stick
really
there.
just say that?
They maintain that
Holy
altitude,
shit.
if you like. They'll stick
It's
at
a
that
stick,
particular
Brandon.
altitude. They will
It's
not
a
go
stick,
down any
bro.
further.
Fall.
Absolute fucking nonsense.
Well, you don't
I
understand
got
basic
it.
orbital
It's a
mechanics, do
space
you? I mean, I can show you
Velcro.
the equations, Matt Brian, but you wouldn't understand them. It's very,
Rumpus.
the equations are very simple.
I've
We're
got
just
an
gonna fall.
absolute way of making you a billionaire. Come up with a method of harnessing Earth's spin to create power.
Well, you can't do that.
Why not? I
Well,
bet
because-
some genius would be able to do it if it was real.
No, we're all moving along. You know, if the equator,
You've got a
you're,
mass that's rotating, doesn't need any energy to fucking get it rotating,
well, it
and
does
we
require-
can't
oh, it
take
did
any
require some
power
energy.
out of that.
Oh, it did require
I feel
lots of
like
energy to get it rotating.
Hold on, Rumpus. Before we
A
take
long
Rumpus
time
off,
Well,
ago,
wind power. Well, wind
a
power
long
is one
time
way
Wait,
of
ago,
using
wait.
energy.
something.
We don't have wind all the time,
In a
though, do we?
galaxy
The
far,
Earth
far
turns
The
away.
jet streams. The jet streams are a function of the rotation. So if you could have a very high windmill,
Come
then you
on.
could do it.
Get your head round
That's
it,
not
and we'll
practical.
be a
That's not
billionaire
practical, unfortunately. I mean, that's why they also have problems getting sea power, for instance. They have dreadful problems trying to utilize
I
the
have a
energy.
question.
Go ahead.
Rumpus,
My mic low?
Thank you, Rumpus. Thank you.
Yeah, it's a little low,
Hold
Jeremy.
on, Jim. I
Not
just said I had a
practical either, eh?
question. Hold on, eh? Okay, Rumpus, you just made a statement that the trade winds are the result of the rotation of the Earth, correct?
Yeah, the streams, not some of the smaller ones, but the jet streams and some of them. The
Okay.
high altitude jet streams are
Okay,
actually the
great.
result.
I
They
don't
go in
need
the
you to
opposite direction.
repeat
to
it.
this.
I don't need you to repeat it. I asked
Well, there's
you.
just some
if I-
wins, and everything needs qualifying. There's always a qualification that's required for these things because you get confused if I don't tell you which wins are not. Some wins are
No.
not the result of rotation. Some are.
All I did, listen, Rumpus, all I did was ask you to affirm that I heard you correctly, okay? So, just for the record, just simply state again what you said about the winds and the rotation.
There
Just
are
a simple-
some wins. There are some winds, like the jet stream, that are a consequence of the rotation of the
Okay,
Earth.
great. Now you have a third document to produce for us that shows that that was empirically determined. Go.
Okay,
Yo, is my mic okay?
You want
Yeah, it's
data
better.
on the direction of the jet streams. Okay, well they circulate
No, you dumb
west-
fuck.
No, he wants causation.
Yeah, the rotation of the Earth.
Okay, dumb fuck. Please produce the documentation where they demonstrate that they scientifically tested these things because they are obviously repeatable, observable, and testable.
Right, so you're
Don't
asking me.
describe it.
Right, so you want proof that jet streams exist, okay? I'll
No,
see what
you
I can do for you. You're just
Get rid
getting
of this
excited,
guy,
Travis,
Brandon.
because you're an idiot. I'm
Wait
afraid
a
you don't
minute.
understand. It's very simple.
Proof that jet
Well,
streams
doesn't
exist.
seem to
How do
get
you get that
any
out of that?
smaller before it disappears, does it? It just disappears.
Yeah, that's like, so when things get small. I mean, if you look at if I were
It
to
doesn't
look
get
at,
small.
if you're looking at an ant, Brian, and then the ant walked away, eventually you would cease to be able to see it. It would merge into the background, wouldn't it? And that's what's happening
Yeah,
here.
but it would
And
reduce.
that causes the jet stream. It's bloody obvious.
I mean,
Brandon,
you don't deny
I'd
that
like
when
to
things
ask
get small,
Rumpus
you
a
can no longer
question,
see them.
if I
Surely,
may.
surely, Brian, you accept when things get small, you cease to be able to see them, or they merge into the background, as per the Rayleigh criterion and optical things and the sensor resolution. I mean, this actually is
It
more to do with the
doesn't
sensor
get that
resolution
small.
than the Rayleigh criterion.
It doesn't get
Fair enough.
that small.
It does. You remember these?
It doesn't.
You're looking at some. This is blurry, expanded thingy. You've enhanced this with your sharpness thing. The actual
Visual thing
I
you
vote
did.
for-
disappear.
I
When
vote
they
for kicking
disappear,
Rumpus if he
when they
says thingy
disappear,
again.
they're only a couple of pixels in size. And of
Uh-huh.
course,
Rumpus,
don't forget, one important point to remember is not only is this important because the sensor has only got a couple of pixels to play with, you've got to deal with the compression, the MPEG compression scheme. Now, if you knew anything about that, you'd know
All
that
right,
discrete.
all right, all right.
Hold
We're
on,
good. We're
hold on,
good.
hold
We're
on,
good.
quick
We're
point,
good. We heard all this
quick
before.
Hold on, Rumpus.
We're good.
Quick point.
Rumpus.
The discrete
Okay, Rumpus,
cosine,
enough la la
the
land. How about
discrete
that stick?
cosine transformation that's used in MPEGs means that things of similar color will, if they go near something of similar color, it will remove them. And it says part of the
That's
compression
how it
process. Go ahead.
sticks to that orbit.
Rumpus, since becoming a flat earther, you're going to have to
Hold
stop
on,
using the
Jeremy.
word
Come on,
thingy.
man.
My bad. Go ahead.
Rumpus, explain to us how that orbit sticks when it's on down its trajectory, and how it sticks to that orbit, how it finds that
Right.
orbit.
When something has a particular velocity, it has a particular altitude that it will remain at. There'll be a stable orbit for its particular velocity. So if it's not at the relevant velocity, it'll change its elevation. So for instance, if you've increased the speed, it would have gone upwards and increased its elevation. They shot the thing out backwards, which means they reduced its velocity, which means its natural orbit for that velocity is below them, and it will descend until it reaches that orbit, and then it will remain at that orbit at that altitude. It'll stick at that altitude.
Sure will. All right, let's move on.
Basic equations. I can show you the equations if you like.
No, we don't need to see the
No.
equation.
No, I didn't think you want a mathematical explanation. Yeah, okay,
Rumpus,
that's great.
enough talking now.
When
Enough
it's
talking.
fired out the back, has it not got
Motion.
linear trajectory? Then
You
so
can't
it's got
find a straight line.
it's in zero. It's in no gravity. It's got
Yeah.
linear trajectory, but then it somehow
Curves?
just develops a curvy trajectory.
Well, let's imagine
after that.
let's imagine this going 17,000 miles an hour.
Imagine, there's the
You could
word.
see from the video that they were launched at about what looked like about 10, 15 miles an
Imagine.
hour. Therefore, it's 10, 15 miles an hour less than the velocity of this launch craft. And that means its orbit's natural orbit, the orbit that's appropriate for that velocity, would be lower than the one it's in at the moment. And it will descend.
How did a
until it-
linear trajectory become orbital? Rumpus.
Right, it's in an orbit. Okay, so it's in the launch vehicle already. It's doing 17,000 miles an hour, let's say.
It's in
Then
space
it's fired out.
where there's no.
So
how
it's
did
fired
it
out.
change momentum from
Yeah, so it's
linear
momentum
to
is
angular
Exactly.
orbit? Rumpus?
Conservation of momentum
Yeah, but you've given it a lower momentum than the aircraft has, than the craft.
in a
the launch
linear
craft.
direction.
Yeah, yes, opposing the direction of the velocity of the launch craft. Yes, and that means
Fantasy.
if you knew anything about orbital mechanics, you've then given it a lower orbital velocity, which means it will descend to an altitude that's appropriate for that orbital velocity.
You
Because
skirted the question.
okay, what was the question again?
The question was, he asked you, it was released in a linear trajectory, and then I
Yeah.
asked you, how did it obtain orbital trajectory?
Okay, it's traveling on 17,000 miles an hour. So if you launch it in a linear fashion, as you seem interested in, backwards by say 10, 15 miles an hour, it will then have 17,000 miles an hour minus 15 miles an hour, which means it will have a
Linear,
velocity.
right? Linear, straight, right?
Yeah. Yes, yeah. So it's reduced the velocity from the 17,000 mile minus 15 miles an hour is its new velocity, and that's not stable at the altitude of the launch vehicle. So therefore, it will descend to an altitude appropriate for that velocity.
So why doesn't
What?
it just fly off into space,
Yeah, it's supposed to go
continuing
straight.
that linear trajectory out into infinity?
That's right, Bubba.
Well, right. when you say linear, all that you're talking about is the instantaneous velocity. This has an instantaneous 17,000 miles an hour. The launch vehicle has an instantaneous 17,000 miles an hour linear velocity, but it's at a tangent. And that's why, but having that still means it goes round the orbits the Earth, even though at any one moment it's going at 17,000 miles in a straight line. Hold on, but the gravity.
You launched it.
Hold on. No. Let's just consider the launch vehicle at the moment. It's doing 17,000 miles an hour in a linear direction.
It's not.
17,000 miles an hour in a linear direction, and the gravity then makes it curve round, and at each point on the orbit it's going 17,000 miles an instant at a tangential linear velocity. But then the gravity then effectively curves it round. It falls towards the Earth each time.
So,
all right. Good story. Good story.
600 kilometers in the air, have you? There's gravity 600 kilometers up.
There is
strong
gravity,
enough to.
Yes, correct.
Strong enough to overcome the
thoughts in your head. Do you not realize that?
Hold on. You made a very important point there, Effie and Evangelist. There is a particular velocity. It's like, for instance, when you spin a ball around your head on a string. There is a particular velocity you have. Hold on, let me finish. There's a particular velocity you have to rotate the ball around your head on a string for it to be near horizontal. If you don't do it fast enough, then it will not get up to that velocity. So, but at each point that ball is going along that circular thing, it's going linearly, and then the tension in the string then pulls it into a circle. But at each point on there, it has got a linear velocity, which is then accelerated by the force of the tension of the string to then bend round. It's basic circular mechanics.
No, it's basic holding two simultaneous thoughts in your mind, two different.
No, you don't. I mean, you don't seem to understand how circular motion works.
Linear with curved motion at the same time.
At any one moment, has got an instantaneous tangential linear velocity.
Satellite is ejected from a platform, let's say, ejected in a. It's not ejected in a curve. It's ejected straight out.
And
so why doesn't it keep going straight out?
Because gravity.
Forever.
Gravity pulls it in just like it's pulling in the craft that launched it, and the craft that launched it going in a circular orbit, and so will these, except at a different altitude because they're going slightly slower.
Yep.
It's basic maths, I'm afraid, basic physics.
You can't possibly believe that.
Oh my God, you don't understand.
It's basic bullshit. It's basic bullshit.
Admittedly, you normally when you're about 15 or 16, you get explained to you how circular motion works, and you don't. Obviously, you've missed that out in your education.
I have a question, and I think it. Okay, hold on. I have a question. I think it'll make sense. Okay, so what is the ratio of mass and weight for these satellites and the rocket out of which they were launched? Okay, so basically, I'm trying to establish the rocket is many tons heavier than these very, 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 very small.
Yep.
Right?
Correct.
But the rocket's not falling.
Correct.
Okay. So
it's
the rocket?
It's in orbital motion, which is actually a sort of falling.
Yeah, I get that. Okay. So it's in its own orbit, correct?
Correct.
I mean, it would be having a certain velocity because it is so heavy.
Right.
Hold on. I don't need you to. No, you can wait. Wait till I'm done.
Okay, go ahead.
So, like you said, a certain object has to have a certain tangential velocity in order to maintain that horizontal orbit. Yeah. Okay, right. Okay, so when you launch these very, 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 so much very smaller objects, right? They're not going to fall because they're lighter than the rocket, and the rocket's not falling.
Yeah.
So these things aren't going to fall.
Right.
They're going to stay right there unless you're going to have to. Okay, listen. You're going to have to lower the shit out of their velocity, not by 10 fucking miles an hour like you said,
no, do it. No,
but like massive.
No, you don't. 10 miles an hour will do it.
Okay, yeah, okay, great. You now show me a paper that has that value.
Okay.
Otherwise, you're making shit up.
No, I'm not. This is basic mechanics. And
show me the paper with 10 miles an hour being the differential for these satellites.
I think in the footage you can actually see it being launched. I think so.
At 10 miles an hour, yeah, that's exactly what I thought. I thought You know what? That looks like about 10 miles an hour less.
Did you? You agree? It looked like about 10.
No, you fuck.
Travis, you've got to calm down and stop being abusive. Just because you don't understand this, it's your problem. You're the one who needs to fix this. And I think one thing you were about to say, which I was trying to think.
Hey, hold on.
Hold
on. Everybody, hold on. No.
Look, look, I stopped for you last time, and now it's my turn.
Said,
no, hold on.
You just
you
said
can
I
come
didn't
back to me. I
understand
want to
something.
finish
I have
the
a
important
question.
point. You can come back in a second. I said a quick important point. Remember, this is all mass independent. You could have a speck of dust, and it's only its orbital velocity that determines its altitude. The mass of the object is irrelevant. The only thing that determines the altitude is the velocity, because the mass of the object cancels
That's not what
out.
you said earlier. That is
yes,
not
it is. You didn't understand it. You didn't understand it, and then.
No, it's not what it. No.
Well, I'm telling you now, in
okay,
case you misunderstood it, it's mass independent.
didn't.
So a massive,
great
space station will orbit at exactly the same altitude as a speck of dust that's going along at the same velocity. So when a speck of dust leaves the space station and it's still got the velocity of the space station, it will remain in the same orbit as the space station. Just because it's a lot lighter, it will not shoot down.
Fantasy.
The difference that's caused is by the velocity, and that was caused by the launch velocity of those things going backwards, which to me in the footage looked like about 10, 15 miles an hour. And then it will descend into an orbit appropriate for that.
Oh, boy.
Go ahead.
I thought things didn't have weight in space.
This makes
have
my
mass.
brain hurt, really. Seriously, guys.
I've just been informed by Professor Bill Bell they're on a spring. I don't know what. Hopefully, he'll tell me what velocity they're actually launched at.
We've got a super chat from Aaron Armstrong who says, "Okay, it's fake. Not my belief at all." Parentheses. What's next, FEs?
We should go over Pebble's thing while we got the rumpus here. See what he thinks.
Yeah, we're definitely going to go over. That's our next thing. Okay, yeah, let's move on. We heard your stories. They were nice stories. Pretty good impromptu.
Well, I'll tell you what, I'll give you a
pinata.
presentation on it. Perhaps in the next couple of days, I'll show you the equations that Travis is interested in and why the velocity will give you a particular height. And then I can go and cite a paper.
Asking for, you know, you was.
The paper will go into the math.
If it's in a paper, then that's fine. I just don't want you showing a piece of paper with the equations on it. That's not what I want.
Well, that's what a paper will do. All it'll do is it show you the equations that give you a particular
listen
velocity.
to me. That's not what I said, you fuck. I said
You need to
I
calm
want
down,
you to
Travis.
show me. Okay, don't tell me what to do, Rumpy.
No, I will tell you what to do. If you start paying abusively like this, I'm afraid you're going to get abused back.
Oh no.
Oh,
Okay.
you behave like a twat. Yeah, you think I don't know why you're behaving like a child here. You think that's somehow clever. You're being a twat
Listen,
now.
I'm going to say it again. I'm not asking you. Okay, listen. I'm going to be happy with a scientific paper that has the equations in it. What I'm not going to be happy with is if you show up and draw on a paper with your own hand the equations. That's not what I want.
Rumpus, check your message from Professor Phil Bell.
It looks like they're initially falling, but all that's happening is they're being launched backwards, and that changes their. And he's just agreeing with me.
Right,
yeah.
right.
Plug your microphone in, Phil. Come and say hello.
So he's just agreeing with me. He's saying that basically the velocity is towards the back, which reduces the velocity relative to the craft.
Sure.
Therefore, it would descend into an orbit relevant for that velocity.
Okay. All right. Good. Story time's over now. Let's talk about our experiment. I talked to Pebbles earlier. Pebbles in the pond, and he had some ideas for what we could do for our tangible physical measurement of the Earth's surface.
Oh, yeah.
And you should see it on screen. Can you guys see it? Okay.
Yep.
All right. So what he was thinking was to it's essentially a variation on some things we've been talking about. It involves creating a straight line, but he had the idea of setting up these posts. Say these are, I don't know, 2 meter posts, right? And then 1 meter up, marking them with a water level. I'm probably butchering it. I wish he was here. But making sure that these are exactly straight, the poles, by crossing like 2 ribbons or ropes of equal length, equal distant on the poles.
Braces. They'd have to be braces.
Yeah, they're like braces.
Yeah, exactly, braces.
And then if these were tight and straight, then obviously this would be a square or a rectangle. The top and the middle would be equal distance apart, and then you'd use a water level or whatever, or this would be the level of the water, and you'd create a straight line on these posts. And then that's what it would look like on a flat Earth, and then on a curved Earth, it would look something like this.
How many of them would you need then at 2 meters apart to get anything that's measurable?
A long way, man. A long way. That's one of the things we talked about. I mean, just going a mile would be like 1,000 poles, right?
It's just not practical then, is it?
Well,
Possibly
you can just
not.
use pieces of wood. I mean,
That's an
you're
interesting
talking about
idea.
Home Depot stakes or something.
And then
you
you
get them
need
for
a
like,
piece of flat land that's perfectly flat for a mile.
nah, you don't. I don't think you need flat land for this. You want something relatively flat. You would use something like the shore of a beach or something where all the elevation is going to be 0.
Yeah, the only
But,
problem is that, again, it's the resolution of those bars. This is where this sort of thing gets into trouble. I mean, something like Brian Mullen's forcing the line thing required on an accuracy of the things joining together at the sort of level of atoms, which is completely.
That's why you use it.
And this is
Level
better.
of
I agree.
atoms.
This is better, but you still need the cross bracing lengths.
Yes, we'd use a precision. Instead of ribbons. Hold on, Rumpus. Instead of ribbons, we'd use it. Hold on a second. Instead of ribbons, we'd use a precision engineered X.
Right, but the trouble is, I don't think that you'd be able to manufacture something to the required resolution.
Well, you would, but the cost
No, you
of
wouldn't.
it's astronomical.
Well, that as well, but the point is, I don't think you could even I could try and go away and work out what the resolution of the lengths would have to be, what the machining accuracy would have to be, and I suspect it's not much more than a few atoms worth, and I don't think you could machine it to that accuracy.
Even
Certainly
if you could,
indeed, it'd be too expensive.
Would be phenomenal.
Certainly, the
All
Brian
you're
Mullen
talking about is Home Depot stakes. They're like $10 for a 20
Just
pack or some
setting
shit.
the posts.
Yeah.
Setting the posts over a mile would take you probably 2 or 3 days, I should think.
Jeremy, the braces that you're using would have to have
One brace.
No, but you're using lots of them.
No, we only need one X. You got your X. You got your precision engineered X.
Then, okay, if you've only got one cross brace system there, you would need to have the holes in the posts.
Precision. They'd have to be precision.
They'd have to be so unbelievably precise. I don't think you could even machine them to the required precision. When you're multiplying this thing by 1,000 and you want just 8 inches across the distance of a mile, then you need to have unbelievably precise machining. But it's certainly more feasible than the way that if you did have just one, if you just had one cross brace there, at least that would be consistent. So then it's a little bit better than the braces, and I think I'd have to think of it. It's a bit more doable than the Brian Mullen thing. But if you just kept one, so if you just had one cross thing and you use that repeatedly to position the posts, so that means that doesn't vary. So you'd only have to make that really precise. But I'm sure there's an error somewhere else in the process. But at least you'd eliminate the cumulative error or the machining error of the cross things. If providing you only had one and kept on reusing it and then fitting it and then producing more things, there's something like there's bound to be a precision issue somewhere, but I can't quite think of it immediately. I'd have to go and think about that one.
So theoretically, I'm just wondering if this would work. It maybe just feeds the idea machine here, but if it were a ball Earth and you tried to do this, and you tried to use these braces to make these poles exactly parallel, eventually they would venture off. They'd be higher and tilted.
They wouldn't be doing what you've done at the bottom there. They would go off in a straight line and eventually go up slightly above the curvature of the Earth. So they'd form a horizontal tangent.
Right.
So that diagram you've got. I mean, let me quickly draw the diagram of what I think would happen.
Not one of Rumpus's diagrams.
It's just be a really quick one. It's really simple. This one.
What if we had a wall? What if we had a couple miles long wall? Is there anything we could do with this X on the wall, or?
Where's my thing gone?
Well, if we were going to do that, why not just use your idea of the spirit level shaped machined, puzzle pieces?
I think the X would be better than those puzzle pieces. Especially if
One
could
thing you
drill
could do
holes.
is you could use a plumb bob on a wall to get the vertical, and then use the X in between them.
Yeah, but that would change those change out. That's exactly what you can't do. That's the whole point. You don't want
Oh,
to use a plumb
shit,
bob.
yeah.
And you need a wall that's a mile long and perfectly level.
No, the whole point is if these braces are what you're trying to say they are, I'm creating it now. So if you had this thing here, and then they had your curved earth down here, I'll make that blue. Let's just make that bigger. Then if you had these braces, God damn it, I didn't group it.
Why you always draw a spherical Earth? What if it's flat?
Well, we're considering what the. I mean, obviously in this. Well, I'm going to. Okay, I can consider the other model in a second. But if we did these braces,
I'm just joking. That was
okay.
a joke.
Right, well, I'm more than. I'm always happy to consider the two cases. Now, what would happen if you did have? If you did this, then you said, right, okay, I'm now going to, and they would join up like this.
And then you touch the X's. Just keep making a whole bunch of X's and keep touching them.
So then
The
would go.
X's, you can't really see them. Can you make them bigger?
There you go.
And so you would. That's
well, they're off a little bit, but okay.
Yeah, no,
we get the point.
I'll try and fix that.
No, we get the point. We understand what's happening.
Okay, we just get in there. So I said we just make that. Oh, damn it!
Brandon's screen had me cracking up last night. He had fucking Snoop Dogg smoking a blunt with some.
Right, so there we go. So this is what would happen. There we go. So I've obviously exaggerated it. Let's turn it around a bit so it's not quite as extreme as that. So this is what would happen. So if you had it like that, well, it's because of my size of my Earth is a problem actually. It's because I've chosen the I needed to put a bigger Earth in that's not quite so extreme. But that is effectively what would happen. You would, if you could make the joints on, obviously you'd have poles in. If you could make one and put poles and fix those in. Oh no, you can't do that because you need to hold them. You need to hold them in position. So you do need more than one. Otherwise, it would wiggle around.
No, well, we were going to use posts as the X, and then put a post in. You mark it plumb. You take your X. You put another post in.
Yeah, but how are you going to keep that post in position? It's going to wiggle around like so. If this is the post here, well, let me make all these a bit thicker, a bit bigger.
We're definitely not going to let my wife hold it because every time I am about to drill something in the wall and I'm like, "You got this," and she says, "Yeah," and I let go of it, it fucking slides down 2 inches.
That's out then.
So that
I think we might be chasing our tails here a little bit, aren't we?
That's what it feels like sometimes, Brian. But there's got to be a solution. I'm not ready to give up yet, man.
Mate, the solution's right in front of our nose, and we all know it.
I know, but I want to be able to falsify.
So if you wanted to, if you only wanted one X, you need a hole. You're going to fix these things to make sure they don't wiggle at all in the slightest whatsoever. So you've got a problem. You do need a fixed, rigid, repeated structure.
All right, Rumpus. What about this? What if we had a precision engineered square, right? And in the each corner of the square, there's a hole, and we fucking. As we get the square up,
but the trouble is you need to make
picture this.
The trouble is you need to right, but the trouble is you need to manufacture 1,000 of these things that are so accurate that so accurate you wouldn't be able to get them consistent enough within the margin of error.
Okay, be quiet, please. Pretend we got a square with a hole in each corner, right? And we got a wall. We can drill holes all into this. So we drill 4 holes into the. We got this all level. Plumb,
right.
It's all level and plumb. The first square. We drill all holes in all 4 corners. Shut up.
I can see what you're saying. I can see what you're saying. Effectively, you're saying you want to drill in.
Shut the fuck up.
I'm trying to agree with you.
I'm trying to be nice to you, but
you're not
making
nice
it easy.
to you.
Okay, just please be quiet so I can finish my thought. We got a square. We got a hole in each corner, right? We drill holes into we drill holes into the square. The holes are the same size as the square. We got bolts to match, same size. You got the square all level and plumb. We swing it. We leave the bottom right bolt into the square in the wall. We swing it up, and you can put all the bolts back in. And then is that how you progress your straight line, or no?
Well, I'm just thinking the problem I was describing about fixing it would be solved is doing what you suggested, with some version of what you suggested. Bloody thing.
You don't need to affix anything. You just keep swinging this square, and you can make a mark. You can make a dot on the top of each square.
And then you could drill them in. So if you had something to fix them to, which is what I'm trying to draw here.
That's an ingenious idea. Yeah, so you're swinging these things forward, and they're locking into each other in place, marking the next spot, and swinging them. Is that what you're saying?
You know what I'm saying? You have them bolted. You have this thing bolted in, and there's a hole where it was before. So that way, when you swing it back up the other way, there's a hole to put it into, so you know that it's in the exact same spot.
You could fix it, and then if you had some wall or something like this, you could attach it to. Then it would be perfectly rigid. Yes. So I've drawn a wall in here, rather poor wall, to what you've then nailed it into or screwed it into to hold it in place, and then you can then reuse the same cross member each time, and then you would only need one super precise
square with holes in it.
I have a question. We're going to go back a bit to Rumpus when you mentioned a tangent, right? If you just have a tangent, it's going to shoot off into space, right?
Yep.
Okay, so, all right, so let's say we set up a horizontal plane about 10 feet high off the ground. It's horizontal. It's level, right? Level to the ground, okay?
Yeah, so...
At what point would you have to start to build longer posts in order to maintain that same horizontal? Let me know that, please.
Well,
depends if floor drops away, surely.
So I've drawn I've drawn a tangent here. I'll put it on first. Initially, I'll put so it's a tangent. Yeah. So the tangent is just here. Well, this is the point. I'll make it a bit thinner so it's a bit more precise. So. Right, so that is now a tangent at this point here. I'll put T for tangent. At that point there, that purple line represents a tangent, which means it'll be 90 degrees to the plumb line going to the center of this thing. So that's what a plumb line would do, and then you want that at 90 degrees. So that's what a theodolite would show you as the tangent, as the horizontal. I haven't quite drawn that accurately, but nonetheless, if you imagine the plumb line was going down, I'll give it a different color so we know what we're talking about. Give that a yellow. So that yellow represents what a plumb line.
Have you remembered my question?
Yeah, I'm just trying to show you, hopefully, by showing you what I'm doing.
What's my question?
I think you're asking what the deviation would be, and I'm saying if you were to build this correctly, there wouldn't be any deviation. But if you're talking about in comparison to the surface of the Earth, I was about to quiz you about exactly what you meant.
No, just stop, please. Okay, so look, if you drew a circle that represents the Earth, and at the top, okay, you've got a vertical post at the top.
Okay,
and then you just
I'll move this stuff here. Okay, I'll tell you what I'll do it. Let me position something drive grammatically so you can see it. Right.
Okay, listen, I'm driving. I'm not looking at what you're drawing. Okay, listen. You've got a vertical post at the top of your circle.
Okay, I've done that
and
here.
And then you put your tangent at the top. It's a 90-degree angle at the top. Yes.
Done
okay. Now, just keep extending that tangent out. My question to you is at what point will you have to put in longer posts so that you maintain that horizontal? Go.
Well, if you're building the posts as I've drawn here, you don't have to do anything else. If you're talking about what the drop is, in other words, how much it is if you were doing this over water, what the gap would be between the tangent and the water level, that is just drop, which is 8 inches per mile squared.
Okay, so what I'm hearing you say is, if you just connect, if we did this in a physical reality with physical posts and physical tangents, it would never curve. It would always remain level, always at that 10-foot height. Is that what you're saying?
No, I'm not. I'm not quite. You need to look at the diagram I've drawn here. You asked me where we position these posts. Are you positioning them on the surface? Are you positioning them such that they got the same elevation, i.e. they follow the water level, or are they following the tangent that you were describing? I haven't quite worked out yet where these posts are.
Okay, listen.
Because if we're following what Jeremy wants to do, they're following
Okay,
the
I was just gonna. Okay, listen. The tangent in your world will increase in elevation as you increase
as
the
I've drawn
distance.
it. Yeah, I've drawn that. I've shown that.
Okay,
now on
it's
screen.
not very hard.
Yeah, I know, and you're repeating yourself, and I've already explained this what I've shown, idiot.
Okay. At what point will you have to build a longer post to maintain that horizontal tangent?
Well, it all depends how you've positioned these posts. If you're doing what I'm doing and sticking them, drilling them into a wall, is what Jeremy was sort of half suggesting, or into some feature that would keep them fixed, then the posts.
Why can you not answer a question?
Because you can't see the diagram. I don't know whether your posts are touching the surface of the water or not. You haven't answered that question. If you're talking about the posts coming out of the surface,
I'm going to drop a post that's going to be 10 feet high. That's my marker.
Is very
That's
flat.
my marker.
Okay, so imagine it's a body of water. So you managed them 10 feet above the surface of the water. Is that the scenario you want to discuss?
If that makes you happy,
well, if that,
go
I need to know, because we were discussing things in a horizontal. We were discussing before about trying to draw something that's in a straight line. Now, if you're talking about putting a series of posts all at the same level, then yes, they're going to curve. So that means that so then we have to answer what you're.
So then they won't be a tangent. They won't be a tangent then.
Well, if you're now I'll put in these other posts that people see. You can't see, obviously, but if I put in this other post here, and they were to follow the surface of the Earth along here, and let me rotate them suitably. I'm not quite sure what it is the gap you're talking about. Oh, damn it! And then this goes here. So you've got these series of posts, which is what you're on your Bonneville salt flats. It's all body of water, say. So we've then got these series of posts. They're all the same height. They're all the same level, and they're curving, and they're not parallel. Now, what is this height thing you want me to account for that's not drop?
Just forget it. You're too stupid. You're too stupid.
No, you're a moron. You can't explain anything properly. I've asked you several particular questions about where these posts are, and you've only now started to sort of imply they're following the curve of the Earth. You didn't say that before.
Okay,
and you need to be able to look at a diagram so that we can save ourselves minutes and minutes of drivel, because you can't be bothered to pull over and look at the diagram, yet you still ask me stupid questions. Pull over, look at the diagram, and in 2 seconds you can tell me whether this is reflecting it.
I gotta get to the Bonneville Salt Flats before the sun goes down. Okay, listen. Brandon.
Yeah.
Brandon, have I been unclear in any of my statements? Do you feel
I
like
was
I'm
trying to
not
fix some technical issues and zoned out.
Okay. Anybody else on the panel? Have I not been clear as to what's happening here? I have not.
But what
I have
you
not
say,
mentioned any curve. I have not mentioned any curve.
Well, you asked me what would be the difference between you said the difference between this horizontal line and something else. I never worked out what the other thing was.
No, I never used the word difference. No, I never used the word difference.
What did you use then? You were deciding you were asking a distance for something, and you never actually described what you wanted the distance to be between then. You just asked me to give you what length would be given, and you haven't described the two things that this length connects to yet.
He wanted to know at what point
the posts need to be as you go along, and it's got to be the 8 inches per mile squared.
Well, I tried that earlier with him, but he didn't seem to agree with that, so I gave up on that line of argument because he's too stupid to understand what I was saying, or too stupid to describe what he wants to describe.
Right. Calm down with that.
No need. You know these things are complicated.
Rumpus, I've got a proposal. Got a little bit of flat land on a curved Earth. Would the verticals be different at either end of this flat piece of land?
Yes, because the definition of
tangents come out from the centre of an alleged globe.
Yes, they would be, because flat in surveying terms means level, and level means that it's curved, as per this other diagram I've got here, where I show you what level means. Here we go, this thing here.
Oh boy.
What level is. Showing you there are some two levels on a spherical Earth, And as you can see, all the verticals are different and local, and all the horizontals are different for each position. And those, but the two.
Yeah, we know the fantasy story.
Yeah,
we
we
know
know
the
about
fantasy
this.
story about what
Yeah,
level
so
is.
this is what's in surveying books. If you were to bother to read a surveying
We
book,
don't care what's in surveying books. We don't
That's the
care.
thing that builds buildings for you, Brandon. That's what they use.
They
That's what
use
surveyors
planar
do.
surveying to build buildings.
They
You know
use,
that.
if you go and look at the books that they use, they describe level in exactly
Who
this way.
cares? We know it says
You don't
all
care
over the place.
because
Everywhere
that's
we
how
fucking
buildings are built.
turn, there's your
That's how
ball. You've
buildings
got
are
it
built,
everywhere.
Brandon,
The worldwide
using this
religion.
system.
We get it.
Yeah, that's how buildings work. So you deny how buildings and surveyors do their job.
Yeah, they build it with flat, level, horizontal. That's how they build
and
buildings.
they go in little steps because they want to maintain a level, as opposed which they wouldn't have to do
Uh-huh.
if they had one that's horizontal.
Thank you for acknowledging that, though.
At the either end of the Bonneville salt flats, we should have a different angle to the level floor.
Well,
Well, they say the salt flats are actually curved, don't you, Rumpus?
Brian, if you imagine that A and B are two ends of the salt flats, can you see this? Can you see there's a position at one end of the salt flat, B's the other. Imagine it's super, super flat, which means it's super, super level, which means it's super, super curved. Then this is the situation.
Super
Then
duper.
the two verticals, the two horizontals would be
I
different.
hope somebody's recorded that.
Yeah, of course we're recording it. Thank you for
Super
another
curved.
clip there, Rumpus.
You
Appreciate
don't
that.
think that's going to be
Flat
pulled
is
out as a
curved.
soundbite?
Level,
It's a super duper curve.
Flat in surveying terms means level, and level in surveying terms and in the globe model is curved as shown.
Do you feel
no
silly
doubt. We
when
got
you
it,
say
Rumpus.
that? Do you feel silly? Like, oh God, I have to say
I'm
this.
relaying to you what the surveying books tell you, which is that flat equals level.
I know, but do you think to
curved,
yourself, I have to
as
say
opposed to
this
horizontal.
again?
Rumpus.
I have to say
You're in
flat is curved
horizontal.
again? Oh fuck.
Flat,
So
that's
in
right.
surveying,
Flat, yes,
in
you wanna
surveying
take that on
terms,
board. You want to take that on
Rumpus,
board. Flat
Rumpus, you
equals
got to leave
level,
room for
and
other
level
people to
equals
talk once
curved,
in a while.
as opposed
Rumpus.
to horizontal.
Jeremy, what's up?
Rumpus, you got to leave room for people to get in once in a while.
I do, but I'm being interrupted. So
No,
I have a
you
short
don't. You
sentence.
talk
I do.
incessant, nonstop.
No,
You
Brandon,
talk
yeah.
nonstop.
I had a 5 or
in surveying terms.
correct. When we talk about
And
the
that's
salt
in-
vulnerable flats, we're talking about
Where did
their
you get
level.
this from?
The Bonneville salt curves.
Yeah, they're salt flats. Which in
Hold on, where'd you
surveying
get this
terms is
flat
level.
equals curved thing from?
Well, it's what's go and look at the
just-
surveying book.
It's imaginometry. You make this shit up as
No,
you go along.
it's in the books that used by people to build buildings.
Let's see
Do
a
any-
page. All
They
right.
don't
Rumpus.
they don't
Let's see
build it by the diagrams in the stupid book. They build it by
They
flat
use-
horizontal
so you're denying the
lines,
books
step
that
by
they
step.
used to build. So surveyors who lay out buildings and long bridges, they use the books that I'm describing, and they use diagrams like this showing you that flat equals level.
No, you don't lay out
which
a
is
building with a
curved.
diagram. You use a fucking level and a plumb bob and
The
those
theory
kind of
they
tools
use
based on flat
is
horizontal.
The books that they
Yeah.
use to do, the people who are qualified to do that have books which give you diagrams like this.
I have
Rumpus,
books
hold
that
on.
have monsters in it and zombies and shit too.
Yes, but they don't go and use that to build buildings and bridges, do they? What was it, Brian? Do you understand this diagram yet? This salt flats thing business with your Bonneville salt flats. Your question.
Yes, but
you're
now,
asking me a
just hold
question.
on. Let me get a word in. You see your image there with the A on it. That horizon, that flat.
Oh, there's no horizon here. Hold on. There's no horizon in here. There's only horizontal.
Horizontal. Sorry, I ain't got my
Okay.
glasses. Horizontal.
Sorry. Okay, let's make it a bit
You
bigger.
see the horizontal? Is that a tangent?
Yes,
they call
correct.
it?
Well said.
Right,
Well done.
now, if we run another vertical to each end of that tangent, they would be not 90 degrees to the horizontal, would they?
I didn't quite understand what you said there. So what am I?
You
what have I got
see,
to do?
you've got your vertical going
Yeah.
down towards the centre of the Earth.
Correct. That's
Run
A, yeah.
another one to the edge of that horizontal black line and one to the other side, and they would not be 90 degrees to the horizontal, would they?
Yes, because the horizontal is only horizontal at point A, at that point there. At this point over here, which is what you mean, I think over here, that's no longer horizontal to this. If I wanted the horizontal for this point C, so you're asking me what is horizontal at point C here is what you're effectively asking me, isn't it?
Yes. And
Correct.
B, the other end.
Okay,
and,
yeah.
and the
Well,
other
you can
end.
see
of
it, B. Well, I've drawn it for you already at B. There, this black line here, now that's why I've repeated the word horizontal
I'm-
here. At B,
I'm not seeing another black line.
you can't see this black line here. You can't see this.
No, you
can't-
see your blue line that points down towards the
Hold
centre
on,
of the Earth.
this line here. Hold on, you can't. Okay, let me make it bigger. Let me make it bigger. Can
I
you see that
can't.
now? That black line.
Where?
I'll make them the black
Oh,
line.
you're looking at that one. I was looking at A.
Yeah, no, okay, and as I said,
No, not that horizontal.
right,
I'm talking
I
about.
know, and you asked me what the horizontal was at B and A, and they're different.
When I meant B, I meant the other end of line A.
Oh, well, I've drawn a C in here. Oh God, why put you in a C? You said you said line C, and I did, and then you agreed with me, and then you said also at B. You said.
No,
Right.
I said put one at B, the other end of the same horizontal.
Right, so I've got C. So you want me? Okay, I'll put a D. So you want me to put a D here? Is that what you want me to do?
Well, that's a C.
Yeah, and I'm going to put a D here.
This is
So
Right.
is that what you want me to? So in other words, right? So are you happy now? So we've got A, D,
Yes.
and C. Right.
Right, now the blue line that points to the center of the Earth,
Yeah.
put that one at each end of that horizontal.
Let me just get that. And that is no longer. Oh, sorry, I'll have to go. Oh, bugger it! I'll have to go back to that. Sorry about that. I will have to dig that out.
All right, Rumpus, are you saying horizontal's not perpendicular from plumb or something crazy?
No, at point A, it's horizontal 90 degrees, but not at C. At C, just like I've drawn.
Hold on, let's
let
just
me draw
finish,
it. Let me
let's
draw
just
it.
finish this, because that's
Yeah.
got to angle in a
Right.
little bit, hasn't it? Yeah.
Exactly. So
Yeah.
that's, and I've done exactly the same over
Go
here
over,
at B.
go over the black line with it. Go over the black line. So we've got a little stick sticking up the.
You want me to go up a bit? You want me
Yeah.
to extend this? You want me to extend it up here?
Yeah, and do the same the other side. Just cut and
Okay.
paste that, paste it on the other side.
Right. Okay. So
So, my understanding, if we could find a piece of land that is flat and level, if this is a globe, our verticals would not be 90 degrees to the horizontal if it's a
They
flat
would.
level piece of land.
point C, because there's another horizontal. Look, Brian, try listening to what I'm saying. Then there's a new horizontal here. Oh,
You're saying horizontal is not perpendicular to plumb. We hear what you're saying.
no, it's not. You didn't understand, did you? Right, here we
Is
go.
horizontal
That is what you're
perpendicular to
saying,
plumb?
though.
Listen to what I'm saying. At point C, there is a new horizontal, which is perpendicular to this arrow. Each point along the surface of the Earth.
No, I never meant that, Rumpus. I meant a piece of land that is perfectly flat, not curved, perfectly flat. Now, if we can go far enough apart, then a plumb bob should not read perpendicular to the face of the land.
Hold on. So what are you saying? You want to build a piece of land that's not curved, but is actually like a cutout of this.
Yes.
You don't want right. So in other words, if we were to get a piece of land and cut out the top there, and you just had, let's make that in the green or something.
I don't know.
So-
My image is gone. I can't see what you're doing now.
Oh God.
It's
Right. So
probably
in other
my
words, you're cutting a chord here, and this would indeed be straight. And the only place that the plumb bob would agree it's 90 degrees is at point A. At point
In the middle.
in the middle. At point C, there'll be another horizontal. This one here. This one here. I'll make that a different color.
I can't see.
There's
my image.
another set. Right. So there's a point C. There's the horizontal at point C, and here's the vertical at point C, which is
Can you make
different.
Rumpus, can you make a point E, please?
Where?
Right side, bottom right.
Tell me where. Here's my pointer. Where do you want me to move it?
Bottom right side of the
Down
globe.
here, below B.
Yeah, below B. Yeah.
You want another point down here, and we call that
E. Yeah, name it E.
okay, right?
All right.
And then that would have its own particular horizontal. So, damn it, I've done it again. Let's give it. So that horizontal would be.
Well, I've
like
got the
this.
image back now.
That would be like that.
What I'm saying is, Brandon,
And
if you dropped a plumb bob at either end of that flat bit of land,
Right.
if it's not 90 degrees to the surface of the Earth, then that would prove that it's a round Earth. But
Okay,
if
now-
it is 90 degrees,
they're
then
always at
it
90
can't
degrees.
be round
They're
because
always
we're going along a flat plane.
right.
Okay,
always-
hold on,
always-
Rumpus. Make one more point. Make a point F in between C and B.
And I'll take with it.
Do an F in between B and C, please.
Okay, hold on. Let me just.
All right.
But it's still ludicrous. Water tells us what we're on.
Yeah, and it follows a level, which is curved.
Why are we even
No, we-
entertaining this nonsense?
Because it's reality.
I don't know. It's fun, I guess, sometimes.
Right, so there you are. So there's the point F. What do you want? Is it
Entertainment.
So what do you want to prove there, Jeremy? There's the point F, and there's the local horizontal. This one here. We got. I'll make that a different color. I'll make that orange. So there's the local horizontal. It's 90 degrees to the plumb bob. So the green line
How
is.
far is local?
How far?
How far is local? Local. How far is that?
Well, every point on the surface of the Earth has a different horizontal and a different vertical.
So you have a point. You have a point, a dot that's horizontal.
No, there's a tangent to that point. So at point
Where
F.
does the horizontal go?
Right, listen. At a point F, moron, there is a plumb.
Okay, hold on.
Listen
Hold
to
on,
me
hold
for
on.
once.
Make one more.
I'm going to explain to you really simply. Take 10 seconds.
Okay.
At point
1 second.
F, a point on the surface of the Earth, you get a plumb bob out. And then you draw 90 degrees to that is your local horizontal. And if I go somewhere else, then you do the same thing. But the two things will have different directions. Finished.
Okay, make a point G. Make a point G on the left side of D.
No, I'm not going to. You're clearly messing me about now. I mean, you're being stupid.
Rumpus, how far?
The fact you're having difficulty understanding, I mean, it's your problem.
Listen, how far does the
drop
horizontal
this.
point go? How
Rumpus,
far does
let's
the
drop
horizontal
it and
point
let's
go?
get on to making a momentum machine off the Earth spin.
Right.
We could make
Rumpus,
billions.
how far does
You made an interesting point,
Hold on.
Brian.
Brian.
If you were to cut off and you actually made something that was horizontal here, and you cut off all the Earth, so that then these points would be at different elevations. So at this point A, if you so this green line, let's imagine you cut this, you managed to create this thing we're trying to do of a straight line, and you cut all the Earth above it off and made it would disappear. Then you would have this straight line. And then the middle point here of this straight line would be at a lower elevation than the two ends, because the elevation is defined as the distance from the centre of the Earth, although it's actually from WGS 84.
So if we drop a vertical on the end of that straight line, it should not be 90 degrees to the straight line like your arrow, isn't there?
Correct. Indeed. This straight line that you've drawn, this straight line, this green one, would not point the 90 degrees here. There'd be an angle to the straight line you built. If you turn this into a rod, into a metal rod or concrete, whatever, and you managed to build it nice and straight, and you took a plumb line, and you would find that it's not, and you took a plumb line out, it would not be at 90 degrees to the straight rod.
How thick is the rod?
But let's do the other way then. What if it
how
was
long
90
does this?
degrees
Hold
to
on.
that flat line? That straight
How long
line?
does this horizontal go for?
At 5,000 miles by the look of
How
that.
long do you want it to?
No, we're making it. We got our plumb line. Now we're going to find perpendicular to that. And how far does the horizontal go for?
As long as you like. It depends on how it's up to you if you want to make it.
How long will it be horizontal for?
Right. So in other words, are you asking me how far away do you have to move from a point before you get a different plumb bob angle? Is that really what you're asking?
Before you get a different horizontal, yeah.
Right. It would be. You could move a micron and it would be different, but it wouldn't be detectable. You couldn't measure it with a device. Every
So
time
there's
you move, if you moved an atom to the right, it would actually have a very slightly different horizontal to the atom to the left.
So nothing
Every
on
single
ball
miles
Earth is
from
level.
degree.
Nothing on ball Earth is level.
Just make a point.
No, everything's on level.
Just make
That's
a point
what
G.
things are level. You're talking about horizontal. Don't get horizontal and level mixed up. Horizontal is a straight line. Levels are curved.
Horizontal is level.
No, it's not. That's exactly where you're wrong. I can show you here level in the
left side of
diagram,
D.
and a horizontal is a straight line tangent to a particular point, and that is a straight line.
I have a question
That's
again.
why it's different.
Okay, I have another question. Okay, I'm at the Bonneville Salt Flats, and I've got a 10-foot 2x4, or let's do 4x4. I've got a 10-foot 4x4 that's perfectly planed, and I go to the right end. We'll call it A, and I've got a carpenter's level, and it's level. I go to B, which is the end of the 10-foot section, and it's level. So that 10-foot section is level. At what point will I have to start to build supports underneath that 4x4 as I extend it into the distance? At what point will I have to start to build posts so that it will maintain that same horizontal level tangent?
Well, it's as I say, if you want to work it on the atomic scale, it changes immediately you move a single atom offset from where you make the measurement, you would have a very slightly different horizontal. But we know that the Earth curves only by 8 inches over the distance of a mile, and it only changes by 1 degree over a distance of 69 miles.
Okay,
it depends what you're doing with this. If you want to build
it's very simple. Rumpus.
When you
oh
ask, hold on, I'm going to make an important point. Planar surveyors are only interested in being correct within a couple of inches, which means they don't have to take into account over the curve unless they're going over, say, half a mile or a mile. Go ahead.
Okay, so what you're saying is that if I just simply put 4x4s end to end at half a mile, I'll start to have to build posts to have it maintain its level because the Earth is dropping away. Is that what you're saying?
When you say end to end, you mean the end to end horizontally?
Oh my God!
They could be vertically. You didn't say what angle they were, you twat. Were these posts horizontal or up or down, horizontal or up and down?
Rumpus, I never said anything about.
God. You never quit. Your stuff is so nebulous. I have to keep on asking you what you mean because you don't define it carefully enough. You moron.
Rumpus. At what point did I ever mention vertical?
What did you mention? I don't know. I'm asking. I'm trying to find out from you how are these posts aligned? Are they vertically aligned or are they horizontally aligned? You didn't say.
I did. Yes. They are horizontal.
Right. So in other words, how long is this straight line? In other words, what you're asking me. So here's this black line, horizontal. This makes it a bit clearer. Let's get this stuff out of the way. So there we have this horizontal at point A, and you're asking me how long is it going to be before this gap between the horizontal. If you were to keep them, and of course the problem with all the things we've been talking about is actually keeping them straight. But let's imagine you could do this. Let's imagine someone gave you a super long, very straight metal bar that was perfectly straight. You're asking me how long would it be before I'd need to support it? Well, at a mile, it would be 8 inches gap. Now, if your thing you were building on could sustain that, an 8-inch gap, then fine. But if it can't, it depends on what you're trying to build it on.
Okay, Rumpus. Now, at 1 mile, there's 8 inches. Okay,
yep.
which means previous to that mile, there was deviation. At what point would that happen, please? Yes, thank you.
All the way along. From the moment you started, it's 8 inches per mile squared, and I can show you the function. And that means it's immediately you move off. There's going to be a difference between level and horizontal, but it will only be about an atom.
Here's my question again. At what point would you say 3/4 of a mile? Would you have to start building those buttresses?
Well, what gap you do? What gap is defining whether or not you have to build buttresses? You tell me what thing you're doing that defines what gap. It's really simple.
Rumpus. Hold on, Rumpus.
Jimmy, let me just finish my point. You're basically asking me what is the gap. If you didn't care like most surveyors don't care about an inch, then they would have no problem. I don't know what an inch is, 8 inches mile squared. Whatever that was, that would be a problem. And if it was over an inch, then it has to do it from point C to point D.
No, just put a G on the left side of D real quick.
I'm not going to put a G on there. You're going to have to make do with what I've got here.
All right.
There's A and C. There's A and D. You have to make use of what I got here. I've got point A with a horizontal, and I've got point C and point D at the ends of the horizontal of an arbitrary length of horizontal that I've drawn. You have to deal with
need it to be longer. Just put a G on the side of D, please.
No,
come on, what side of D?
I can make this
Rumpus, come on.
He's not trolling you. He just wants a G.
He is trolling.
I want to put a G up there so I can make a chord from B to G.
No, you can. We've got a chord here. This green line is the chord.
On your guitar, you mean?
All right, let's pretend we had a chord from B to whatever you got. Where do you got?
From D
Where's
to C.
the chord?
Here, this green line here is the chord from D to C.
Much of a chord right there. Can you go from D to B?
Okay.
Make a new chord from B to D.
Okay, I will.
Leave that one there. No, leave that one there.
Okay, all right then. Okay, I will do a new chord from D to B. There we go. So there is a new chord. I'll make that in.
All right. Let's say we had a chord and we knew it was straight, right?
Yes. Imagine this. So we're giving you a straight bar, really incredibly straight bar. You managed to get someone to manufacture it somehow,
D to B.
and from D to B, and then you would have to drill and remove all this earth that's in the way, and then you would end up with this nice stonking great chord, and you'd have to remove all the earth to attach it from D to B.
Right, and then we poured water, and then we poured water in between D and A.
And it would all accumulate. All that water you've poured in would all accumulate here.
Make a point G for where we're going to put the water in.
It'd all run off, wouldn't it?
Put a G in between D and A so I can show where we're going to put the water in.
No, you have to make do with reusing point C. Here we go. So there's the water. Let me just.
We're not using C for this. Absolutely not. This is
we are exactly what we are doing. All right, so there the water would. Let me just draw some water in here. It would all pile into this. But there
Is
we
this
go.
a comedy show?
Yeah.
Apparently, I think Jeremy's obviously not
About
interested in
50% of the
so
time, this is a comedy show. That's correct.
So there we go. So there's where if I put in a certain amount of water, it would all pile and sit here, and then
In the middle of the cord?
in the middle of our cord, it would all accumulate here, and then only
Lumpy water, okay. Not bendy,
Why
but
wouldn't it
lumpy
run off
water. A
the
lump of
end?
water there.
because
Nice lump of
water
water.
tries to get as close as it can to the center of the Earth, and the closest point to the center of the Earth is in the middle of this cord, this brown line.
It goes to
That's
the lowest
the closest-
elevation, you mean?
Exactly, and that's closest to the Earth is this point here, and this point here, D, is higher up. It's further away from the center of the Earth than point C, and point B is also further away from the center of the Earth, and therefore also higher.
Higher
Because
elevation.
because the whole point about level, these dotted lines, is they're all at the same elevation, the same distance from the center of the Earth.
Uh-huh.
That's what defines elevation, the distance from the center of the Earth, although you should really use WGS84 because GPS works to that, but we'll do this conceptually from the center of the Earth. These points are all along a dotted line. They're all the same distance
We
from the center of the Earth.
get it. We
They're all-
get
Well, I'm not
it.
sure everyone does, Brandy. I appreciate you've got it, but I'm not sure everyone else has.
Can you
So we
say
got our
that image?
cord. Now what?
Well, I just poured some water. No, I was waiting for Brian to give me some next instructions.
Last
The
time
water's
I
gonna do the
put
exact
two
same
sheds
thing
when
on
we
both
put
models.
how far it was to the center of the Earth.
Okay,
It's
We
funny how
poured
that
some
works.
water into
Make
it.
a
It will all
plumb
go-
line. Hold on. Rumpus, make a
Water
plumb
looks
line
a
at
bit
C.
lumpy.
Do a plumb line at C for us.
Okay.
No, we needed that other plumb line there. Just can you
No,
do it?
I copied it. You didn't lose
All
it.
right. All right.
There's the plumb line at C.
So all the water is going to pool at C, you're saying?
Correct. If
On
you had a
both
cord
models.
that cut in like this, the water would
On
pool
both
at C
models.
Yep.
until
A little bit
eventually.
more anti-clockwise, Rumpus.
No, it'll do that.
All they did was create an inversion. It's just an inversion of what would happen on the flat
Why
Earth.
does it,
That's it.
why does it pool there and bend around the curve everywhere else?
Because we've dug a hole. This is a hole we've dug. I asked Jeremy asked me to produce a cord, which is effectively a hole.
So
and
if
therefore it's going
water is in a hole, it's flat and it gathers, and if it's
No, it's
not,
not
it
flat.
curves around
No,
the outside of
no,
the ball.
no, it's not. It's not flat. It's still curved. The curve, although I haven't done it very well.
Inward
yet.
bowing, so it's an inward
No,
bowl.
okay, let me draw. Okay, you want it to be more
Concave,
accurate. Okay,
right?
hold on. Let me
You
know.
pour a lump of water.
I will now
Yeah.
show you what shape. I will now show
Physics
you
of
what shape.
water are changing here, gentlemen.
Literally on a
Rumpus
flat
is setting
surface.
All new parameters for us.
Right,
Let's
it'll
go.
look something
A
like.
flat
Center of the
surface
Earth and
is a
water
bowl on
There we
this
go.
imaginary Earth.
There we go. It'll look something like that. Is the shape it will have.
A bowl is a cup.
So it.
I don't
you
know
put in
what a
that
flat
amount of
surface is. Maybe a frisbee?
A flat surface is a level surface, which is a curved surface, as described by this level A
Right,
dotted
right,
All right.
right.
All right, Rumpus, do me a favor. Draw a line from the top of the point B. And there, draw a line from the top of that plumb line to the top of the plumb line at A.
You want me to draw a line from B, the top of B, here,
To the top of A. Yep.
here, yes.
All right. Now draw another line from the bottom of the.
No, I've given up on you, Jeremy. I'm afraid. I think I've the bother.
Jeremy broke the rumpus.
I thought we were getting somewhere. We just
Jeremy,
you gave
I'm
up.
very accommodating. I'm very accommodating. I'm too patient. I've been accused many times of being too
I
patient.
got a thing with plumb lines I want to show you. Just draw another plumb line from the bottom of B to the bottom of A.
All right then. I can't. See, I'm just so generous. I know. I'm just too nice to you guys. That's my problem. So there we go. There's the bottom of A.
All right. What would be? No, that you got it inside the earth, bro. On the top.
Oh, okay. Right. So
You
you
can't
want me
do
to
it.
draw
We can't do anything underground.
So you want me to bid from B to A?
Yeah,
here.
we've actually. Yeah. From the bottom, but don't make it go into the earth, though.
Well, you don't have any option. It will always do that. If you
No,
have
it
it on the
won't.
surface of the Earth, yes, it will.
Put the
You draw
center
two-
above the Earth. That's
Well,
all.
in which case, then it won't. It will. Okay, well, if I draw that, then it will be above.
Yeah.
It will no longer be touching A and B. A and B will be. It'll be above A and B at both points. If you want to draw a straight
Yeah, but
line,
it's touching the line. It's good right there. You're good. What's going to be
What
the
is-
difference between those? What's going to be the difference between the height, between the length of the top one and the bottom one? If let's say point A and B are 100 meters.
Very minor.
Yeah, you're talking about the drop over 100 meters. I can tell you what that is if you like.
No,
No,
it's
not
not
the
the
drop.
drop. He's talking about the distance between A and B at the bottom of the plumb line and A and B at the top of the plumb line.
Right,
And
the
we
difference between
calculated
recurrent
this.
arc-
We calculated
difference
this. It
between
was
the
like 1 millimeter after
it's
like a
very tight. Yes,
mile.
talking about the
It's ridiculous.
Yeah, if you're talking about the distance between the length of this straight line here and the length of the blue line arc, and what's the difference between those two, then it's incredibly tiny.
Yeah.
Yes.
Yeah.
Super tiny.
Did
Although
you
we
like
do
my
have that
idea with the square?
micron, they can measure microns, can't they? Isn't that what Lego's doing? Maybe we could take the string to them and ask them to measure it.
They can
Rumpus,
actually.
did you like my idea with the square with the holes in the corners and the pegs in the wall? Is that a good way to make a straight line if we could just keep rotating
I was thinking, yes, this business here. I was trying to think of where there's going to be a precision problem somewhere. And if you just repeated, particularly if you had a wall like this to actually drill holes in, once you've positioned it, to hold it all rigid.
Yeah.
I mean, obviously, it's completely impractical, obviously, having a wall that's a mile long like this in which to drill things.
Can I have a couple questions for the Rumpus?
Go ahead.
Okay, Rumpus, so what we were talking about before with the, we all agreed, the only thing that we've all agreed on, which, I mean, we pretty much agreed on everything with a little bit of contention, but in the end kind of agreed. So we all agreed that if we were to build a wall just hypothetically 3 miles long and then one parallel to it, say however many feet over, say 10 feet over. If we were to build 2 5-foot or 2 walls that are level with the water, with a body of water or a water level, and we flip them in toward each other.
Yeah, we went into this before. You have to pivot them around the. I don't know if I've got that previous diagram here, but you need.
Hold on, I think Brian had a question, Rumpus. I don't think you let him get to the question.
I didn't, but I must. Yeah, I was the one you done pre. Okay, go ahead.
So let's picture a 20-foot hump over 8 miles. I got that video coming out too. It was harder than I thought it was in real life, but I mean, doing it practically, lay it out, it's harder. It's not that much, but it is detectable and measurable. But so let's say
I'll do that, Rumpus.
let's say this. So we have a 5-foot high wall, and then 10 foot. We have another 5-foot high wall. They're thin and they're lined up with the water at the top. We follow them in toward each other, and they touch in the middle, but they don't on the end. Okay. So
sorry, you broke up there, Brian. I didn't catch the word there. Key word that you were using.
You're a little low, Brian. I don't know if you can get your mic closer or what, but you're a little low today.
I hope that. If that's better, okay.
Oh my gosh, so much better. So much better.
Brian, quiet. Oh, Jesus Christ.
Here's my question.
Quite quiet. Turn your volume down or something.
I'm turning it down. I got it. It's better though.
Okay, so let's say we don't start at the ends. Okay, we set up water levels. Let's say
water levels. We've only got water levels involved now.
Let's say 10. Okay, 10 foot above the canal. 10 foot above.
Which is a particular fixed height above a piece of water next to it. Okay, great. Yeah.
The top of that wall is 5 foot higher than the water.
Great.
Or the bottom of that wall. The bottom of that wall is 5 foot higher than the water. The top of that wall.
Okay, all right.
And the top of the wall is 5 foot above the water. So it's a 10-foot wall. Okay, we're above the water. We're basically.
Sorry, you said the base of the wall was 5 foot above the water.
Yeah, exactly. And then the top, it's a 5 foot wall, so that puts the top of the wall 10 foot above the water.
Right, yeah. So we've got a 5 foot high wall that's suspended somehow 5 feet above the water. Okay.
All right, it's in free space basically. Okay.
Right, yeah.
Now, so we're looking at that from a God view. We don't know if it's flat or curved because it's an equator. Okay, it could be a straight line or it could be an equator. It could be in other words, it's a straight line from a God view, correct?
A God view. Sorry, you're using words I don't know. What's a God view?
Up above, from up above.
You're in a plan view. Okay, right. Okay, that's a different term. Right. So from a plan view, you're looking down at now. Okay. Right.
Okay.
Right.
Now, okay, if you tip that wall over to the left, okay, the beginning of that wall, let's say so the wall's 5 foot high, we tip it over to the left. Are we going to be able to measure 5 foot from the equator
the equator? What do you mean by the equator?
What the equator we just talked about, Rumpus? We don't know if it's flat or curved.
Use the word equator. I don't understand what equator means.
It's the straight line with a plan view.
That's called an equator, a straight line in a plan view.
I'm just okay. Forget I said equator. Okay, if we tip that wall over to the left,
Right.
is that straight line? We don't know if it's flat or curved yet.
Right.
Okay, we're working on that. We tip the wall over to the left of our straight line, of our level line. Okay,
Right.
and it's a 5 foot tall wall. How far is the middle? We're going to be able to measure the middle 5 foot from the straight line itself.
How long was the
To the
wall?
left. Rumpus,
How
do
long-
it to the left of point D. Make it a point G.
No, we're not going to do that. So, how long is this wall again?
You pick, man. You pick.
If it's a mile long, the middle.
No, it's longer than that. Let's say it's four miles.
Okay,
4 miles long.
Okay, let's do the okay, let's get the info on that then. 4 miles. So if it's
In
4
free
miles,
space.
Yeah, okay.
So we're
Okay, I'll just do the calculation here. So we need to know the drop for 4 miles.
wait a minute now. Don't forget that the bottom of the wall is level. Okay, don't forget that.
Yeah, I'm not.
So there's no arc over the water. Okay, it's level with the water, whether it's flat or curved. So, so you can't put an arc on a flat ground now. Don't do that. We don't know if the ground is flat yet or curved. What we have is a 5 foot wall, 5 foot above the canal. Okay.
Right.
We put water levels 5 foot above it, and that's where we started it. Okay.
Right. So if we've got a 4 mile wall, that means that the axis, the chord, in fact, that I was drawing here, this green chord here. So it's such a mess now.
I think what you've got on screen, the answer is in there somewhere.
Yeah.
We're just
So
not
indeed.
seeing
So
it.
what
It's right there.
Right. So in other words, what you've got the wall.
He doesn't even have a point G in there. What the fuck?
Yeah. Very funny. Right. So you.
Don't draw a chord because there's no chord at this point. All we know is that the wall is level. Okay, it's level.
You're gonna have to rotate.
You're saying level is curved. Okay, so I want to put you to the test.
That's going to move, and I was just and that's going to and you're going to have to rotate this wall around an axis, aren't you? And the axis you're going to have to rotate it around is a chord.
Why would you rotate it? The whole thing is level, buddy.
Yeah, but I thought sorry, didn't you not say we're trying to put it on its side? You said, well, how far would the top of the wall be when you...
Yeah. We're turning it 90 degrees. Yeah, okay.
Yeah,
that's what you mean by rotate.
Right.
Okay.
You've got to rotate it around something. And the point
Yeah,
is,
we're just pushing
we
it.
talked about a couple of days ago, you've either got to say,
We're gonna
fix
listen.
the end. Hold on, you've either got to fix
Listen,
the end.
there's no degrees. There's no... Listen, Roberts, let me say one thing.
No, let me make my point. You've got to do what either Brandon wanted to do, which is to rotate it around the middle, or you do what I want to do, which is to fix the ends, and then you push it over. And the axis is between the two ends, which is a chord.
Rumpus,
Okay.
Rumpus, I don't think you understand.
Whoa.
Rumpus, you
Don't add a
don't
chord in there.
understand.
You have to, because that's the line that joins the two ends, which we're going to rotate it around.
No, it don't, because we're 5 foot in the air above the water.
Well, you're still going to rotate. You're still going to rotate it around an axis. It's the whole thing, and so you've got to pick where that is. And if you do what I want to do, which is to draw a straight line between the two.
There's no axis.
There
There's
is an
no
axis of rotation, you moron. If you're going to rotate something, you have an axis of rotation. So if we're going to turn this thing 90 degrees, you have to decide what.
Wait, if flat is level, bro. Hold on. Whoa. If flat is level, if straight is level, okay, and we are consistently the same height above the water. Don't forget that there's not even 1 degree over 4 miles. There's about 1/30th of 1 degree. It's so don't start adding chords, okay? We're talking in real life here.
We have to rotate this thing, which means when you do a rotation, you have to have an axis of rotation. So you have to pick what the axis of rotation is going to be. If it's in mid,
It's
if you're
just
sitting
a
there in air,
fulcrum. It's a fulcrum. It's not an axis of rotation.
You're a moron. If you listen, you'll understand. To rotate something, you have to rotate something about an axis. You have to pick where that axis is about which you're going to do this 90-degree rotation. And the axis I'm going to pick is the straight line between the two ends of your wall, and then rotate it around that.
Don't you understand? I could take a Slim Jim and arc it over the equator, and I could just roll it
I don't know what
to
a
the
Slim
North
Jim is.
Pole. I could roll it over to the North Pole.
I don't know what a Slim Jim is.
It's a gas station
A
sausage.
hose.
Those little gas station sausages and the individual wrappers.
I could take a hose, Rumpus, a tiny hose.
But this is
Lay
rigid. This is rigid, Brian. So it means
Right, but I'm laying it on the equator. You're already assuming there's a chord. You're assuming that it's curved. I'm just telling you in real life.
Okay, in real life, you have to say,
And listen, Rumpus, in real life, we don't know if what's under us is curved or flat. So we're suspending it.
But if it's rigid, yeah, but if it's rigid, it's going to rotate. If it retains its shape, it is going to rotate about an axis, and you have to then say, well, if it's going to rotate around its center of mass or around something, or I've held the
So
end.
what degree axis is that going to be, Rumpus?
I didn't understand the question.
Yeah, I know you don't, because there is no degrees. Okay, it's going to be a wall that is. It's going to be a wall that is level with the water. Okay, and it's 4 miles. There's like 1/30th of 1 degree. So don't bring in chords or something. All I'm asking you is how far would the middle fall?
Yes,
It would-
but relative to what? And if it's
Relative to 5 foot above the canal.
right, but it's not. When you rotate it, you're going to rotate it about an axis, and that will determine how far the top will move away from the point. If you, for instance, if you decide to rotate this wall around 20 feet, or say a mile underneath the ground, you rotate it.
Okay, Rumpus.
So you've got to decide what
If
you're
I
going to
take
rotate it around.
Rumpus, I take a stick, okay? If I take a stick and I put it's 5 foot tall. I hold
Put it
it.
at point G.
I level it with a water level 5 foot above the canal, okay? Now, I fall it over. Are you trying to tell me the edges of the edge of the stick are falling less than the middle of the stick? It's going to fall over. How many feet the wall is tall? We haven't even determined what the bottom of the damn wall is, Rumpus. That comes next, and we can't even get past this.
Yeah, well, you're never going to get anywhere without a point G. I'm telling you right now.
Shout out to Point G. Shout out to Point G. That's brilliant, Jeremy.
Did you not remember
We
what
definitely need a G spot.
we discussed?
What are you going to do without a G spot, Rumpus? Come on.
Where's that my bloody thing?
Stop playing games. Put a G on there.
Put a G on it. Zoom back in, Rumpus.
Right, hold on. Right, here we go. This is
Do it to the left of D. Left of D.
the original. Oh, by the way, there's a little picture.
Don't lose that other work, Rumpus. We're going to need that later.
Well, I'm not. No,
That's a work of art.
I think that's destined for the bin. That. Right. So remember what we're trying to do. Is that a suitable diagram? Okay.
Just make it to the left of where D was. Bro, what happened to all the stuff?
I'm gonna start this one again.
Let's go.
Get rid of that, I think.
Oh, don't destroy your work.
Yeah, I'm gonna get rid
There
of
we
that.
go.
Right.
Put
so,
G to the left of.
Okay. So when we create this wall, I'm gonna have to copy that.
We're going to build a
Oh, man. What the
a
fuck?
4 mile
Rumpus?
wall
You're no
that
fun.
hovers over water.
You're no fun, Rumpus.
Yeah, I know.
Rumpus, I don't think you understand. Brian, put your camera on and explain it.
Hold on. I'm just trying to draw this arc that Brian's having a bit of a problem understanding.
Oh, he doesn't understand arcs.
Let me just hold on.
He's
At
only
my house right now. At my house right now, I have a wall with a straight wall, about 8 foot tall, with a grid of nails, with a water curve drawn on it. I have two free space flat bodies drawn on it. But before I do all this, before I put it on the screen, I'm trying to figure out how much he thinks the middle of the wall is going to fall with 0.03 of a degree.
Right, an 8 foot wall with nails on the top means it's a prison.
No, I mean it's the wall of my carport. We walled it in with block, and so I put some grids, and then we drew an arc, and we got arbitrary numbers representing, and we pulled some 45-degree lines, and it seems like we got a way to flip a arc on its side, pulling a 45-degree and then a different 45-degree. We can rotate that arc in free space. That's what we're trying to do.
Right, but yeah, Brian, but what you don't seem to understand is you're rotating that arc around a point. There we go.
In free space, right.
Right, so here we go. So you've generated an arc like this. So this is an arc which I've taken out from this circle, which was there. And so you're now going to rotate that around something. So
why do you have a cord? Why do you have a cord?
Brian, you have to decide what you're going to rotate it around. Now, what you and your previous thing with lots of different poles and the tombstones idea was you were going to rotate them, your thing, you had lots of little posts along here.
Well, that's because there's no degrees that distance, you know. To get 1 degree, we have to go 69 miles, right? So we're trying to give you a distance that it pretty much assumes itself fairly flat. We're trying to bring it up into midair. So I need to know how far you tried to say the end swings out.
Right.
Is what you tried to say. You can't have the middle swing. You can't have the middle go further and the ends pull back. You can't have both, bro. You can have one or the other.
Right. So what you were going to do was to have, I've drawn these all different lengths, sorry about that. You were then going to rotate them, all of the points individually, these tombstones, around each individual point of here, which means you would lose all of the information. You would have no gap. What you need to do is to rotate this thing around the axis that joins this point here to that point there. Oh,
so you've drew a cord. So no longer. So what we need to do now, okay, is we need to set that wall up as as thicker than 5 foot in the middle. Then well, hold on, listen. If you're going to put the wall on a cord, then it's got to be taller than 5 foot in the middle.
Right, now you've got to rotate it around an axis. Now, hopefully, I just described earlier, what you were proposing to do before was simply to rotate all these posts around the points where they're in contact with the water or whatever.
I've got no problem with that. Now, tell me if you have a problem with this.
But that is a problem because then you will lose the curve of the actual curve you're trying to measure.
I have my curve.
Listen,
okay,
Brian, this is important. This is the key
I've already
point.
listened to you, bro. You're not listening to me.
No, I am listening to you. And if you understood this axis of rotation, you've got different axes of rotation for each tombstone that you had along here. You need to have a universal axis of rotation, i.e. a chord.
Okay, then now, okay, I just listened to you now. If we're going to have a universal chord, okay, then the middle of the wall has to be bigger than 5 foot, dumbass.
The middle of the wall.
You can't have.
Yes, from the axis, the distance. This wall. Imagine. Okay, so let's make this wall a bit thicker. Let's make the this thing Let's conceptually 5 feet. So let's make that conceptually 5 feet. This thing. It's a tall thing, and we're trying to draw.
We're gonna flip it over like a banana on its side. You know what I mean? Like pretend you got a banana.
Right, so if it was rigid, everything would be fine. You don't need to worry about this.
Okay, you just keep going, quit talking. So now, the stick in the middle.
So you said, keep talking, then you interrupted me. So if it was rigid...
I said, quit talking!
Oh, no, well, okay, well, I want to finish. I just make the point. If it was rigid, none of this problem with about the axis would, as we talked about, it would go kick backwards, as Brandon called it. I'm just saying you'd rotate it around, and it wouldn't be a problem. But because you were trying to do all these tombstone thing in the middle, then, unfortunately, you're rotating about lots of different points.
So go ahead, wait, hold on, before you keep jabbering, fill in the bottom, fill in the middle. Like you said you was going to do, because if we're going to put it on a cord, then we're going to make the wall taller in the middle. So go ahead and do that.
Yes, okay. So you need to put in, yes, you'd need to fill in this space. This, let me try and draw that in there.
It needs to be all stuck together. Like imagine flipping a banana on its side.
Wait, hold on, Jeremy, hold on.
All right,
Just give me 1 second, dude. I don't even want to lead him to that. Okay, I want him to fill in the wall thicker.
So you'd have to, there's the black represents the wall. And then we would have to fill in this bit here, which I've got in blue now.
Okay.
That's
so now,
and then you'd rotate it around the base here.
Okay, so that would be equivalent. I'm with you, bro. So that would be equivalent to a 10-foot tall pole in the middle. And 5 foot tall poles toward that. What are you talking about? No, you just filled it in.
Listen, you're now going to this suspended. So in fact, what you've got this thing suspended.
Oh my God, he wants his cake and he wants to eat it too, people.
I'm giving you reality, Brian. I know it's complicated for you, but you're going to have to deal with it.
It's not complicated, bro. It's not complicated.
You don't understand the issues
involved.
It's
not simple. No, you don't understand, bro.
No,
Trust me, you don't understand.
I understand the geometry. You've suspended this thing. If you want to include the 5 feet, which you obviously put in for some reason.
Now, if you're going to draw, let's see if you can picture pre-space. No, get rid of the globe underneath it. Start a new page.
Okay, let me. Well, okay. Whoops. I'll move all this stuff. Oh, damn it. Hold on.
Give me 2 parallel lines in free space.
Hold on. Oh, you don't. I was going to copy this.
Then you could give me a side view of just what you drew, like a cutting a penny in half.
Right. Is this? So you don't want me to? You don't want this anymore?
This well, don't erase it completely. Just start a new page.
Okay. What do you want me to do?
We got to do this in free space. Okay. We got to do this in free space. And what I want you to do is draw me 2 parallel lines.
Okay.
Okay. And represented by 10 foot between them.
Okay. There we go.
All right. Now. Okay. Now. Okay. Separate them a little bit more.
Okay.
Okay. Now.
This is a plan view. We're looking
now,
down.
from a side view, Rumpus.
Okay.
From a side view.
You want a side
draw
view?
me cut a penny in half and put
Cut what's in half?
and face it to me.
Right. So you want me to draw you what we see orthographically? So you want me to just draw you a
an arc.
Okay. Oh, you don't. I thought you wanted a wall. Okay, that's arced. Okay, right. You want me to draw an arc? Okay.
like a banana or something.
Okay.
Yeah, but we got to fill in the bottom like you just did. We're gonna because we're in free space now.
Right. Okay. Hold on. Jesus, what the hell happened there? Right. So you want an arc? Okay.
Yeah, there you go. There you go. Okay. And now, okay. Now draw the solid. Connect them with a cord, and shade it in.
Okay. What the? Why are you not filling that in, you bastard? What did that? Oh, okay. Oh, because I got the default. Sorry.
Do you talk to yourself like this when you're alone?
Yes. Well, I suppose I'm trying. Oh, Jesus Christ! I need to. Hold on. I need to go into line mode, and then I can.
I'm just trying to pin you down to one
That's fine.
axis.
Right. There we go.
I'm not going to give you both. Okay, so now you got two of them.
So the wall you've built, the wall you've been describing, will form a long. Oh,
Well, don't talk. We're in free space. Don't talk about nothing else.
You've got this wall going along here, above.
Don't talk about the Earth, dude. Yet we're in free space. Okay.
I'm not showing the Earth. I'm just showing you. You asked me. You've got this wall above this curve.
Just follow me along. Follow along with me. You might not agree with it, but okay. You got two of them now. We're in outer space, bro. You got two of them, and they're pancaked against each other. Okay, they're pancaked against each other. They're 5 foot tall.
Are you happy that I've drawn? Are you happy that this thing here? Let me just draw. It's a curve. Hold on. Let me just get this point here.
Okay, just listen.
Right.
Okay, so now you got.
Right. So
listen, you got them pancaked against each other.
So does this represent what you're talking about? We've got the base here of the wall, and then the top.
Yeah,
of the
you
wall.
can. No. Get rid of everything but the purple.
But that means we haven't got a wall. The wall is not okay. But I thought you wanted. This is not a wall anymore. I thought you wanted a wall.
Yeah, it is a wall, Rumpus. It is a wall. It's just thicker at the end.
It was changing height, isn't it? The purple is no longer.
Changing height, but it's in free space though.
Yeah, but hold on. The wall is only 0.
We're not going to go all the way to the end, Rumpus. Just bear with me. We're not going to go all the way to the end.
No longer height. I thought you wanted to have a wall that was a constant height. Following this curve.
No. I did it first, but right now I don't.
Okay.
You've done away with that.
Go ahead. What do you want me to do now?
Pancake them. Okay, now picture in your head you pancake these two.
What do you mean by that?
Against each other. Okay. How else could you pancake them? Just put them flat against each other, where it just look like a little bit thicker. It'd just be a little thicker. Okay, you match them up exactly. Put one on top of the other, however you want to describe it.
Well, hold on.
You're gonna have.
Hold on. We've got the plan view up here. We've got the plan view of these two walls here. Plan view.
This ain't a plan. This is a side view.
Yeah, and this is the side elevation.
We're looking orthographic. Okay. Now you're just gonna set one on top of the other, so you can't even tell there's two of them. Okay.
It's orthogonal. Let me just.
You don't even have to do it. You just got to picture it, Rumpus. Just got to picture it in your head.
So what do you want me to do? I don't understand what you want me to do.
Imagine
Just picture putting another one. Picture another one right on top of that one. Okay. So you can color it blue. Color it blue. Just color it blue. Color everything there purple blue. So the other wall is blue.
Right.
Now now do away with the purple wall. So now you just got a blue wall because it's on top of the purple wall. So you can't see the purple.
Okay. So there we got two. Right. So from the side view, we can't see one because they're. Imagine we were looking along this way.
Right. Okay. You're with me now, still, right?
Well, yeah.
Now,
I'm just.
Now,
so
now
we're looking along with the arrow here. These two things, and this is what we would see if we were here as an. So if we were here as an observer, so if this is an observer point of view, just here.
Okay.
Where this arrow, at the end of this
Dude,
arrow.
you don't need to draw different pictures for anybody in their heads. I'm just trying to get you to follow me.
I do because you get confused all the way.
I ain't even done nothing yet, you fucking idiot. I ain't even done nothing at all.
No confusion.
You think you know where I'm going, but you don't. Trust me.
What are we doing? I know what we're talking about. So we've got this view here.
Well, let's let Brian get through this. Let's just let him get through this thing.
So we're looking at this. For some reason, you want me to.
He's in retard caution mode, guys.
No,
he won't even.
I'm being exact and doing exactly.
You won't humor me, bro. You won't humor me in free space.
I'm just making sure we all know what we're doing.
Okay, now, you got one wall on top of the other. Okay, now you do a God view from. Okay. The wall's going down to zero. We know that. Okay. We know that, Rumpus. We know that, Rumpus.
Okay.
We know. Okay. Now check this out. Okay. So now what we have is 8 miles. Listen, man, dude, really?
The wall is varying in height. You've got me to draw a wall that's 0 height at the ends and it's got a height in the middle.
No, I just took away your fucking excuse. Is all I've done. Okay, this is nothing. This is just a wall that looks exactly like you see it in free space right now. That's all it is.
Is the black line here the wall, or is the blue part of the
wall? Tell me when I can make my point, bro.
Go ahead.
Just tell me. Okay, we got a pancake. Now we do a God view. Okay, we fold the rounded parts out away from each other. Okay. Now the middle of the just bear with me.
Well, hold on. We're the plan view up here now, so we've moved up here now. We're at the plan view. So
now we're at the plan view, and we fold them away from each other, rounded parts away from each other. So the axes are touching.
So what do you want me to
do? Flip the blue one over vertically, so the two are.
Flip the purple one.
The plan view. Oh, right. So you want to see what this would look like vertically?
Flip the purple one. Flip the purple one.
Right. So you
only got one axis now. Flip the purple one. Opposite, opposite the blue one. Okay, now touch the axes together.
He hasn't flipped it.
You want me to turn this upside down like that? Okay, you want me to do that? Is that what you want me to do?
No, other way.
Yes, that's it.
Touch the axes. I want you to touch the axes.
That way.
There you go, right there. Okay, now, if you have a flat axis in the middle of that, okay? If in the middle of that, in the center, if I have a 5-foot pole, okay, and I fall it one way or another, it's going to hit the tip of either circle, correct?
So we're looking at, is this a plan view I've drawn here now, this thing here, this purple and blue thing, is that from a plan view?
Looks more like lady parts.
Doesn't matter, we're still in free space. We're still in free space.
Right, okay, but we start.
This must be a joke, surely.
Right, okay, so but the thing is, this is a wall that's not a constant height. At the moment, we've got a wall that's 0 height at this end, and a 0 height at this end, and then it goes, and it's...
0 height, right, 0 height.
It's 10 feet or something, okay, if that's what
it's 0 height, exactly, Rumpus, it's 0 height.
So we've got a wall that's changing in height, okay. What's the
point? It's 0 height, okay. Okay, so what we can do from what we see with this is if it's 0 at the ends and it's 5 at the middle, okay? So what we could take from this is we could take 2 poles in the middle of an 8-foot mile stretch of water, okay? And let's say or 4 mile stretch of water, okay? We take a 5-foot pole, we let one fall to the right, we let one fall to the left. Okay, and they would represent that. Okay.
No, they wouldn't, because
Now-
you've not put them on an axis of the chord between them.
Well,
You're
lean the
doing
wall back
exactly
up.
what You're doing exactly what you did with the tombstones, where you're pivoting them at different points. That you're not getting a universal rotation along one axis. You're changing the axis about which you're
Okay.
rotating it. which
Now
you haven't
spread them.
understood.
Spread. Okay. Now look. Put 5 feet in between them.
To do that. Is that
Okay.
what you mean?
Yeah, that's good. Okay. Now you got 5 foot in between them. Okay. So what you did here. Okay. Let me explain. What you've done here is the edge of that wall is you have the top of the wall. What you is you trying to on the earth you're trying to fill in the top being higher and the bottom being thicker. Okay. And what I'm trying to show you here is that in free space, if you stand them up, okay, then you're going to have, if you had a stick in the middle, and you had 2 sticks at the end, they would fall just how you see, exactly how you see, man. There'd be no, if you didn't go all the way quite to the very end, okay, if you went to the, like halfway to the edge, and you have a 3-foot stick, okay, you have a 3-foot stick and you fall it away, and you fall another 3-foot stick away, that's exactly what you're going to see, okay? There's no pivot point in free space. There's no pivot point. So you can't arc the wall at the top and shade it in at the bottom too. You either have an arc. Wait, how am I trying to explain this?
Yeah, I'm
Okay,
no idea.
okay, now if you pivot them toward each other, if you pivot them toward each other on a God view.
A plan view. So
Yeah, plan view.
It's just, I've still not worked out whether I'm looking at a plan view or not here with this purple, pink, and blue thing. Is this a plan view or not? Or is it so? You did it.
That was the plan view. Now the plan view.
Initially you agreed it was a side elevation, and now you've turned it into a plan view. Okay, well you can do that, but I mean, right? Because you turned them 90 degrees, and that was when you flipped them. You turned them from a side view into a plan view at that point, did you? So this is when you've laid them down.
But there's a reason. There's a reason.
I think the only way this is going to work is if I would
just don't try and mislead me again, bro. Just do. Okay, now you're gonna hang a plumb bob down to. Hold on. So now you're gonna put them in plan view where they're arcing and they're right next to each other, 5 foot away from each other. Okay. So the bottom is flat, okay, right? The bottom is a flat equal pivot. Now you're going to hold a plumb bob from the middle, and it's going to hang down 5 foot, okay? And then you're going to hold on just before you say anything. Then you're going to go halfway to the end. On either side, you're going to hang a plumb bob down 2.5 feet, okay?
I tell you what.
Now you're going to angle them toward each other. Okay, the one in the middle, 5 feet. Hanging down 5 feet and 5 feet, and they're gonna touch at the flat point. At the flat point, they're gonna touch. Okay, in the middle, they're not gonna touch. They're not gonna make it where it's only where that wall's only 2 foot high, and you have a 2 foot plumb bob hanging off each one 5 foot apart. They're not gonna touch because you only got one axis, bro.
What the hell is this proving?
I have no idea what you mean. I'm afraid.
Explain this to me.
Right,
I'm holding him to his axis, man, because.
Brian, I think the only way to get around these problems of these things is if I were to do it inside a 3D program, which I can do, perhaps on another occasion. We can arrange for tomorrow or something.
No, couldn't.
All right, but here would be my point.
Because then I can
you
move
can't
things
put us
around.
through that again.
No, I don't want to go through it again either. But what we could do is, if I were to do in this thing, then we wouldn't have this. If you can see this 3D program I've got here, we could.
Here's my point. You still ain't heard my point, bro.
Well, hold on.
My point is, here's my point. We just did all that. You only want to hear my point. Is that correct?
Brian, I'm just point out, I could draw everything you wanted to describe.
Dude, we just did all that, and you don't even want to hear the punchline.
Well, let's hear the punchline. I do want to hear the punchline. If you didn't get to the punchline, because we
here's the punchline. The punchline is, if I have a 0 foot stick at the end, if I have a 2 foot stick quarter of the way, I have a 5 foot stick in the middle, okay, and they're touching each other, okay, and they're the same distance down, and I fall them out towards. If I fall them away from each other, then they're going to be 10 foot apart in the middle, okay? They're going to be 4 foot apart a quarter of the way and 0 foot apart at the end, bro. Okay, so if I space them same walls 5 foot apart or 10 foot apart, and I've had a 5 foot stick in the middle, okay, and I had a 2 foot stick a quarter of the way and a 0 foot stick at the end, they're gonna be repelling away from each other at the ends. The middles are going to touch, okay? So in other words, I just took away one of your axes. All you did is slip in 2 axes, try to slide the middle out, and I'm trying to tell you, no, you can't do that, man. If you're going to go level with the water, then you have to have different heights from the water. So so 3 separate size sticks would show deviation, okay, on a globe, period. If you take that free space program you just did or whatever, put it in free space, make it in free space, put it back down on the earth, then boom, we could do 3 separate sticks, one at 0, one at 2 miles, and one at 4 miles. Okay, and we could pull them down different heights of the water, representing free space beneath the water, and lean them toward water level, lean them toward each other. And if it's a globe, okay, then it's going to show deviation at the ends. Period. That's the punchline.
It's not really practical, though, is it, Brian? Building a wall 4 miles long.
No, that's just it. We don't need the wall. All that was to demonstrate that the stick in the middle is going to be taller, and we could butt them against each other, and he can't fold out the end. See, what he was trying to do earlier is he's trying to make a wall. We have a 0 foot mark at a chord. If we draw a chord, then that chord ends at 0. He's trying to make the chord end at 5 foot in the air, and then trying to fill in the bottom also. If it's a chord, that means it goes from 0 to whatever the tangent is, right? You see what I'm saying? He's trying to give you a chord. He's trying to fill it in, make it a 5 foot bulge, and pull it back 5 foot. In other words, the chord ends at 0. If you draw a chord through a circle, you start at 0, okay? And whatever, depending on where your chord's at, would be the distance between the straight line and the bulge. Does anybody follow what I'm saying?
No. We have no idea.
Are you kidding me? Yeah, you do, Rumpus. You do, Rumpus. Any chord, Rumpus, any chord starts at 0, correct? Any chord is going to start at 0 foot elevation, correct? Just like what we drew.
Yes, that would, that part I understand, yes.
So if we cut a chord through Earth, we could have a 0 foot stick, okay? We could have a 5 foot stick in the middle, if that's what the bulge is, and a 0 foot stick at the other end. Your axis, you're trying to shit the axis, man. In other words, the chords is going to be just like we drew. It's not going to be a wall that if we're accurately depicting the water as drawn a chord, it's going to go down to 0 at the end. You can't draw the bottom. You can't draw the bottom thicker, man, and the top bulged. You can't do both, bro.
There is no way we can test this, bro, is there?
This is what I'm telling you. The way to test is just how I drew it, okay? You take 2 parallel lines, okay, over 4 miles, okay?
We can't do that, mate. We can't fucking get a straight line for a couple 100 foot, let alone 4 freaking miles.
What do you mean? No, not up and down, left and right, Brian.
How are we going to do a 4 mile left and right perfectly flat?
We can make
do
straight
that with
lines.
optics.
If you're not worried about the up and down factor, and you're only worried about left or right, we can do straight lines indefinitely.
Right. So in other words, if we pull 5 foot down at the end, okay, and 2 foot down a quarter of the way, okay, they should be be bulging away, man. In other words, my point is the chord goes down to 0. The chord works its way down to 0, and he's trying to keep you at 4 foot or 5 foot with the wall. He's trying to keep you at 5 foot at the end when a chord in real life goes down to 0. That's about as plain as I can put it.
I will try and construct these walls in a 3D program tomorrow or something, and then you can give me a clearer thing of what you want to do, and then we can see what it is you're claiming, because at the moment I have no idea.
Let me read a super chat from C4. Shout out C4. The Earth is definitely not flat, but thanks for letting us come and hang out, Brandon. Thank you, C4. Appreciate you stopping in. Although I disagree with you vehemently, but thank you very much.
I think Jeremy pretty much has had it pegged when you just basically take a what do you call that game, croquet, or take a ring or any arc and just take 2 of them and put them next to each other, okay? and let them fall away from. You let them fall away from each other.
If you do that, it has to be. Hold on, Rumpus. If you do that, Brian, they have to be connected, or you have to know you're on a flat surface. It works on a flat surface if you just lay 3 sticks down.
Yeah, that's why I did it in free space. That's why I did it in free space, man. Because here's the thing. Okay, if we're gonna assume the middle of that water. The body of water, we're gonna pull 5 foot down. Okay, and we're only gonna pull 2 foot down at the ends because the water's supposed to be curving. Okay, then it's not gonna line up in reality, man. In reality, it's not gonna line up. But if it's arcing, then it should. I don't know. It's so hard to explain, man. But I will take a look at what you show in 3D. But as far as arcing the ends out, I don't think that's fair. When we're predicting a chord, I don't think it's fair, man.
Yep, I will try and do a for some reason I've forgotten how to bloody bend stuff in this. I'll have to go and remind myself. Oh, there. Oh, God. Yeah, it's
but you do make shit impossible to get to the point, though, man. I will say that, dude. You're a tough cookie to deal with.
Yeah, because you didn't basically follow my help so that we help the explanation. I've now no idea what you mean. No one else understands what you mean. So we're in the position now you just spent the wasted the last.
Yeah, because you didn't let me get right to my point. You even confused me for a minute.
I let you, and because I let
No,
you
did not, bro. You confused me for a minute, bro.
You had 10 minutes to basically say what you liked, and because you were
Bro, there was no reason for you to cut in at any point of me trying to get you to draw something in free space.
Right. Because of that, because I didn't cut in any, stopped cutting in, we've now no idea what you're talking about. If I had cut in and we'd all followed along, we would all know. But
no. You say we don't understand, and it's because you kept cutting in. Like I said, you even confused me for a second.
Well, because I didn't.
You're slick, dude. You're slick, is what you think you are, man.
Because I wasn't able to nudge you along and explain each stage. We've now lost you. We had started off on rung 1, and you jumped to rung 10 in your head, which is usually faulty, and so we've no idea where you are. Whereas if I'd been able to help you along each rung, we'd all know what you meant, and then we'd all be able to talk about it. But because you want to go off and talk by yourself for 5 minutes, we've now no idea.
Down to 0. There's going to be a chord between one end of that 4 miles and the other end of that 4 miles. It's going to be 0. So don't try and paint another axis, bro. You're going to try and paint 2 axes.
We'll do it in 3D, Brian, and then you can absolutely point at things and say, right, I want you to do that and that. We all know what projection we're doing, and I can move things and manipulate things exactly as you want.
Fair enough.
And then it'll be really super clear.
All right, guys. I look forward to that. We're gonna round it out tonight. It's about 7:45. We'll go through final thoughts. I mean, everything is clear to me. I think we definitely have a very detailed and cohesive plan of action. So I hope the audience is clear on everything that took place today as well. So we'll start off with final thoughts. We'll start off with, let's see here.
Can I go?
Yeah, sure. Yeah.
Okay, because I'm just about to get to the salt flats, and anyway, so I think that it was clear that we demonstrated that at no point, if you laid connecting planks of wood end to end, at no point will you ever have to build buttresses or support beams or posts to maintain a tangent that will eventually gain an altitude above the descending and falling away surface of the earth. The questions that I asked tonight, pretty sure, absolutely clear. Each time I brought it up, tried to change the situation, it was the same thing. At no point will you ever build lengthening posts to maintain a tangent which increases in elevation, because the earth's flat. Thanks.
Thank you, Travis. And then we'll go back to Brian Leakey. Brian?
Yeah, I'm here. Sorry about that, man. Yeah, I'm interested in doing this in 3D. So I'll end it with this. I'll say, so picture a bridge, okay? A bridge that we say is flat. They say it's arcing in the middle, okay? So if we pull, okay, so they say the water is curving. So I'm not trying to say just pull a line down to the water and measure it, okay? They say the bridge is arcing and the water's arcing. Fair enough. So what we got to do is we got to pull, then to touch the water, we basically have to pull two longer lines at the end, or either a longer line in the middle to get down basically to a free point in space that would be farther underneath the water. So, in other words, if you have if you have two longer hanging plumb bobs at the end, because you hung a pole over the water, okay, then the one in the middle is going to be shorter, okay? So you have, or vice versa. Let's just say we have one in the middle that's longer than the other two, okay? So forget the water underneath the bridge. We just have, at each cord, we have two 20-foot plumb bobs, and in the middle we have a 40-foot plumb bob. Okay. But what I was trying to say is we have three 20-foot string lines, and we got them hanging down, and the one in the middle is supposed to be hanging way less than the ones on the end. But if you pull them 90 degrees, they're all three going to stick out 20 foot. But at an angle, then there's a slight deviation. And that's what I'm putting to the test now. So that's what my video is going to show, and I'm almost done. But I'm still interested to do it in 3D software. And I appreciate the time, guys. Thank you, Rumpus. Take it easy.
Thank you.
Thank you, Brian. Global virus foe.
Great show as usual. Keep it up.
Thanks, man. Rockwell. Jeremy.
Yeah, this would have all been cleared up with Leaky if you would just put point G in your diagram. All right, and everyone keep brainstorming. We're gonna come up with something eventually. Brian might have something here. We'll have to, maybe make a video on it or something so we can see it like coherently and model it or something. And good job.
Thanks, Jeremy. Jimbo.
I hope at least one of you cheap cunts out there buys the flashlight I recommend. Thank you.
Yeah, pop that link in chat there, Jimbo. Change some people's lives tonight. George.
Oh, no real comment. I think Rumpus has done a sufficiently fine job tonight to humor you all. You don't need my input.
Thanks, George.
Okay, thanks, George. Howard.
Brian, Leakey, I want you to listen back to this interaction and tell me if you understand what you said. Thanks a lot.
That's a good comment.
Leaky, I got faith in you, Brian. You're the man, bro. I got faith in you, bro.
Me too, Brian. Thanks, Howard.
He's trying. He's trying. So I have to give him that.
Aaron.
I was just listening the whole show, and dude, that was some funny shit. Jeremy getting Rumpus to draw all over his fucking drawings, dude. That was funny shit. So, great show. Cheers to everybody.
I was literally crying at one point. I was crying.
I'm too kind is my problem.
Sorry, Rumpus. I couldn't help it.
Yeah, well, I was going along with it. I could see what you were doing, but there came a limit. But I'm just too generous with my time, I suppose.
Thanks, Aaron. Essie.
I'm just so glad you take time out of your day for us, Rumpus. Holy shit, I'm beside myself for that.
Thank God. We wouldn't even know what to do if you weren't here, Rumpus.
Well, thank you very much. I appreciate
it. Shout out Jimbo and his flashlight. Please, somebody buy it, please.
So I can STF you about it.
And great show, Brandon. Thanks, bro. Good night, everybody.
Thank you, SE. And here's the link I'm going to put in the YouTube chat to these life-changing flashlights. TN42. Bob Dole is not there. Did I miss anybody? I don't think so. Yeah, Rumpus. Yeah, go ahead.
Yeah, so I've got the diagram on screen. This is what poor old Travis was having a problem with. This is shows a tangent. This is the drop. So if you wanted to build them, buttress it up, as he called it, then you obviously just simply have to allow for the drop, which at 1 mile is 8 inches. So you'd need to put a support, and it would vary. As you can see, I could give you the formula. It's 8 inches per square mile. So every point you would have to put that 8 inches times the mile squared, and then that's how much you'd have to pad it out, or fill in as a foundation, which is what the size of these arrows are. Which obviously, but that formula, by the way, only works until about 400 miles, which is quite a lot, or it might be longer than that actually. About 400 miles at least, anyway. So that gives you the thing that Travis wanted. But the thing to taken away is that flat, in surveying terms, is the same as level, and level is curved as a constant elevation, and horizontal is a straight line. So if you can take that on board, that would be you'd
Highly
Just
illogical.
remember. Highly,
That's,
it's one of
no,
the
do
survey-
not. No one
it's
remember that.
All the buildings that you work to and all surveyor operations work to that principle.
All right, thanks,
Finished.
Rumpus. Appreciate it. Okay, I'll be back. I will record some of the after show, and just give me a couple minutes. Thanks, guys. Appreciate you guys being on the panel tonight. Good stuff. Okay, thank you, everybody. We didn't get to the crash that happened today. SpaceX rocket that crashed and burned. Pretty cool wipeout. And we didn't get to the NASA founders again. We kind of got carried away with the experiment stuff. But we'll see. We'll see. Tomorrow, I will definitely get to those two things. And I hope everybody has a good night. And we'll see you then. Hopefully, I can work out my technical issues between now and then. We'll see. I'll try that link you gave me, Mark, and see if that works. Anyway, have a good night, guys. And see you tomorrow.